Hi students, very good evening everyone. Yes, so GATE 2025 EE examination finally conducted, and yes, we were waiting for our authenticated sources to give us some authenticated information, and that's the reason we were on hold before coming in front of us. Right now, me and Hemant sir are there in front of you, and very soon our team will be joining shortly. So yes, guys. Before we start up any analysis, before we start any discussion, can you let your opinion? I mean, how the paper was, especially those who have written the today's paper, they can give the best, description how you felt the paper during the exam hall, whether it is easy, moderate, difficult. Because once we see the questions after the exam hall, our temperament is different. But during the exam time, how the questions were there, were you able to handle them or not, right, guys? So, sir.
Yeah. So from our information from our sources, I think the weightage for each of the subjects are like this. For maths, we've there are some 9 questions. I think we'll add it in the
correct, sir.
So
yes, guys. So
sir, for maths, there are total 9 questions, 5 1 mark and 4 2 mark questions for maths.
So dear will write like this: 1 mark question and a 2 mark question. Yes, sir.
And networks, there are total 6 questions from network theory, and 2 1 mark and 4 2 mark questions.
Okay, 2 1 mark.
2 1 mark
and 4 2 marks. Okay, the weightage also I'll write. This makes it 10 marks.
Yeah.
Mathematics as expected 13 marks.
Yeah. And from EMF, we have 1 plus 2, 1 1 mark and 2 2 mark questions.
Okay, that makes it 5 marks for
5
EMF.
marks, yeah.
So I think recently, earlier it used to be in EE EMF for 2 to 3 marks, but last 3-4 years suggesting that at least 5-6 marks they will get.
Average of 8 marks usually, 7 to 9 marks on an average, and I think they again came back to 5.
5 marks, right.
And from digital, it's only 1 2 mark question.
Okay.
So 0 plus 1.
Oh, this is little unusual, but okay, so it's EE, so we can expect that. So yes, guys, all this data is memory based on the exam hall. This is data coming up. It may be some plus or minus. So if you know any corrections in this, most welcome to comment, because all this is memory based. Okay, so if you feel that any data is deviated, you can also tell your comments, especially those who have written the examination. Sir.
Yeah. Sir, next signals. Analog. Analog electronics, we have 4 questions total, sir.
Okay.
2 1 mark and 2 2 mark questions.
Okay, that makes it 6 marks. So analog and digital is like 8 for EE.
Yeah. And then signals and systems, controls. So this is where I think we have a good weightage this year.
Okay.
So for signals, it is 4 plus 2.
Okay, so signals 4 1 mark and 2 2 marks. Okay, so
marks.
that means 8 marks of signals.
And for controls, it is 2 plus 4. So 10 marks.
That is 10 marks.
Yeah. And power systems, 3 plus 3.
Okay, dear. So writing down the core also, EE core, power systems, machines, power electronics. And dear, very soon we will start solving the question also. But first let's talk about the highlights of the paper.
For both power systems and machines, it is 3 plus 3. So 9 marks.
9 marks each. Yeah, that's what usually, core you'll expect 9 marks easily, 9 to 10 marks easily.
And power electronics, as usual, 2 plus 4.
That makes it 10 marks, yeah. And measurement, I guess it would be not that high.
1 plus 1, 3 marks.
1 plus 1, that is 3 marks. Okay. And APTI, we all know it is 5 plus 5, so there's nothing great to discuss about that. Yes, and I think the data that we are getting with respect to MSQs is roughly 4 to 5 MSQs. That's the data that we have got.
Yes.
Okay, 4 to 5 MSQs are there. Okay, NATs are there, roughly around 25 NATs are there, and around MCQs roughly 35. Okay, there may be plus minus 1, based on this is, as I told, it's memory based. Okay, so MSQs, NAT and MCQ, this is what is the data.
But again, earlier, NAT and MSQ combined, we used to have 25 questions, sir.
Okay.
And the remaining 40 questions used to be MCQs.
Correct. Usually. So this time MCQs is more.
No. NAT is more, I believe, as compared to the earlier weightage.
Okay, correct. Yeah. Sorry, correct. So yes, dear. Sir.
Yeah.
What do you feel about the weightage of digital, EMF, or other
Yeah,
subjects?
digital,
Whether it is
as
weightage?
usual, the weightage is usually a bit low as compared to the other subjects, and that's the usual trend in electrical paper every year that we see. And furthermore, yeah, EMF, yeah, I expected at least 7 marks this year, but yeah, it's 5 marks. Sometimes a few questions of EMF and maths will be overlapped. So yeah, you can put those questions, maths questions, mainly vector calculus questions, either in EMF or maths. That's up to you. And we will talk to Surendra sir. Surendra sir will share how the paper is in terms of the toughness level of the electrical paper, right?
Hello?
Sir, Surendra sir.
Hemant Jeppo.
Sir, you are on live right now.
Okay.
So just can you share how the paper is?
Yeah.
Grade
What I
2025
found electrical engineering paper is moderate to difficult, Hemant.
Okay.
So what I found is electrical circuits questions are very easy except one coupled circuits question.
Okay.
And the electrical machines questions are also dead easy.
Okay. Machines is very easy.
Machines is very easy.
Network theory is quite easy except for one question.
Except one question.
One question. Okay.
And then I found signals and systems questions are slightly difficult because I don't have much depth of that subject, but what I felt.
Okay. Okay.
Signal questions are little on difficult side.
So personally, from your point of view, signals is a bit tough.
Bit tough.
Okay. Okay.
Okay, and power electronics questions are straightforward questions.
Okay,
but students who remembered or memorized the formulas, I think they can easily solve the problems.
Okay, so remembering formulas, so there is no trick as such in power electronics.
Yeah, no.
So it's straightforward.
And nice. One more thing, analog questions are also on easier side only.
Okay.
2 questions came from op-amps, ideal op-amps that too.
Oh, nice.
One question came from I think amplifiers.
Okay.
So a bit on easy side. Okay, one MOSFET question came.
Okay. So 2 questions from op-amp, 1 question from amplifiers, and 1 question from
MOSFET.
MOSFET. Okay.
MOSFET. Yes. Okay. And coming to the measurement subject is also direct questions came. Okay. 1 mark question on percentage errors.
Okay.
And 1 question on Wheatstone bridge.
Okay, so from measurements, Wheatstone bridge question as well as also error question.
Error question.
Okay.
1 2 marks and 1 mark.
Okay, sir.
And I'm just going through the remaining questions also.
Okay.
But I found those who were able to perform signals and maths really well. Okay. They will be definitely expect a very good rank. Even aptitude questions are also slightly on difficult side, Hemant.
Okay, so they might be trickier then.
Yeah, especially 2 marks questions.
Okay.
So especially the questions are little lengthy. I found more MCQs are there rather than NAT, and aptitude questions are almost MCQs.
Okay. Yeah. Okay.
So English also there is 1 question, 2 questions I think from English, general English.
From English there are 2 questions.
Okay. Logical reasoning 2 questions are there.
Okay, sir. And remaining questions are from quant or spatial aptitude.
Yeah.
Okay, sir. Then thank you, sir. Then.
Okay.
Yeah. So just now you have heard what Surendra sir has said. Overall, whoever did well in maths and signals and aptitude 2 mark mainly will be the game changers in this exam. They would have really scored well. Okay. So yeah. So we'll start with the questions now. Okay. Yeah. 1 second. Sir.
Okay.
Sir, Giri sir.
So if you see the overall paper.
Now Giri sir will share his experience also regarding the paper. Yes, sir.
Yeah, actually, if you see the overall paper, it's not too difficult, it's not too easy. Okay. There are some questions which are a bit tough. They are taking too much time to solve. So, yeah, time management is very, very important there. Okay. And some questions are direct formula based questions. For example, 1 2 mark question is given. That is direct straightforward.
In which subject?
EMF 1
power electronics. Okay.
That is directly straightforward.
So power electronics 2 mark question is okay. Digital electronics.
Digital.
Okay, it's a straightforward question.
It's a straightforward question. Only 1 question given from digital electronics.
Okay. Which topic, sir? If you remember.
That is from the gates only. Some Boolean function is given.
Okay.
Then you have to minimize the function and you have to identify the correct logic gate for that.
Okay, fine. Oh, it's a logic gate question then.
Yeah. And EMF 1 question is given from coaxial capacitance. That is for 2 marks. Okay. That is a direct. I think it's a very straightforward question. The remaining questions are
probably.
Yeah, the
Okay.
remaining questions are maybe a bit difficult.
Okay. From
So
EMI.
power electronics, power electronics, almost all questions are simple except maybe one or two questions.
Okay.
But coming to system, really this times solving of power system questions is really a tough task.
Okay.
Because see, one question given from economic load dispatch,
Okay.
that is not a normal question
Okay.
where you have to find out the cost coefficients. Then you have to calculate, and also you need to have a depth of the subjects to answer that question.
Okay. So see
So
guys,
because
power
yeah,
electronics faculty is saying power systems faculty is saying ki power system questions are really tough. So you can understand ki
yes,
this year we can 100% say ki power systems is very tough for GATE 2025.
yes,
Yeah.
yeah, it's really a tough one.
So
Because
questions
see,
mainly came from the unconventional areas.
yes, yes, yes.
Okay.
So that means you need to have a proper analysis in the examination hall itself.
Okay.
You have to
So
do the
you should
analysis,
have that
proper
aptitude
analysis.
towards power systems.
Yes,
Yeah.
yes,
Okay. So that logical
And,
thinking approaches should be known to you.
yes. And even if you see networks questions also, few questions are very simple.
Okay.
Okay, but few questions are a bit tough.
Okay. So
But
tricky again.
even the question, what I'm saying simple, that also requires some kind of analysis. You need to find out some formula. One question is given from transients, where
Okay.
you have to find out the
Sir.
capacitor voltage, and later you have to equate it to some value and find out the time.
Okay.
Because that question is talking about how much time the capacitor is taking to charge. See,
Okay.
that kind of question, I mean, in the GATE examination hall, to solving means the student may feel difficulty.
Okay.
So like that, I'm saying the paper is what not an easy paper. Okay, so the people who select the questions properly, okay, and answer them and concentrate on them and answer them, they will have definitely have a good score, and the maximum you can expect 70 and not more than that.
Okay.
Even we need to think of student quality also. Yeah.
Okay. Okay.
Top mark will be not more than 70,
70.
as per my knowledge.
Okay.
And the people who get around 50, they will be definitely in top 500.
Okay. So sir is saying ki whoever gets 50 plus will be in top 500, and the top 10 score will be on an average of 70. 70 plus will be the top 10 score is what sir is saying. Right, sir?
Yes.
Yeah. So again, the paper seems to be a bit easy, at least in a few areas, but apparently it is not easy. Sometimes it is a bit tricky. So if you can understand the trick, yeah, it is easy for you probably. And if you can't understand the trick, maybe you'd have got some answer. Sometimes it may be correct, it may not be correct. So whoever looks at the trick and identifies the trick will be the game changer in this particular exam. Okay.
Yes.
Yeah. Okay, sir. Then we'll see you in the studio then shortly.
Yes, definitely within 5 minutes.
Okay, sir. Then. So yeah, guys, we'll start with the paper solutions discussions right now.
Yeah.
Yeah.
So I have got a few maths question and one signals question as of now. Okay. So yes, dear. You can also comment if there are any questions with you, or you can share the questions in the Telegram as well. Let's get started, dear. Okay. So as expected, linear algebra important. And that is the matrix A given to you. The matrix A that is given to you is 1, 1, 1, minus 1, minus 1, minus 1, and 0, 1, and minus 1. And another matrix B given to you 1 by 3, 1 by 3, minus 1 by 3, and 0. Okay, the system of equation AX equal to B. The system of equation AX equal to B has what? Okay, the system of equation AX equal to B has what? Okay, option number A, infinite number of solutions. Option number B, finite number of solutions. Finite number of solutions. Option number C, no solution. Option number D, unique solution. Very clearly, you can look into the matrix and say, that definitely, the determinant is going to be 0. Two rows are similar, two rows are identical. Okay, so determinant will be 0, and hence there cannot be unique solution. Okay, and if it has more than one solution, it will be infinity only. So there is nothing like finite number of solution. Only thing you have to figure out is between infinite and no solutions here. Okay, so if I just write down the augmented matrix A is to B. If I just write down the augmented matrix A is to B, okay, so that turns out to be 1, 1, 1, 1 by 3, minus 1, minus 1, minus 1, minus 1 by 3. Okay, so entire second row of the augmented matrix also is similar to the first row, 0 minus 0 plus 1 minus 1 and 0. Okay. So dear, definitely, because both of the matrices, whether you talk about the A matrix or whether you talk about the larger matrix, both have similar rows, 2 rows are similar. Okay, so rank of both of them is not 3, rank maybe 2 or below. Okay, both the rank of A as well as the rank of A is to B are definitely not 3. Okay, now whether the rank is 2 or not, it's a very easy calculation. No need to go for any echelon method or any row transformations. You can simply say, see dear, these two are similar. Any minor you form out of it will give 0 value. But if you take the first and the third row, okay, if you take the first row and the third row, take these elements 1, 1, 0, 1. Okay, now if I take this as a 2 cross 2 minor, it is a minor of A as well, it is a minor of the B matrix. Okay, so and when you calculate the determinant of it, when you check the determinant of it, it's definitely 1 minus 0, and that's answer is non-zero. That means whether you talk about A matrix or A is to B matrix, both of them have a 2 cross 2 non-zero minor. Both of them have a 2 cross 2 non-zero minor. So that means the rank of A as well as the rank of A is to B. Rank of A as well as the rank of A is to B, okay, is equal to 2. Both the ranks are equal and less than the number of variables, and hence the system should be having infinite number of solutions. Hence the system must be having the infinite number of solutions. Yes, dear. Okay. Have you solved this question? What is the answer you have got? Any comments, dear? Yes, we need your updates also, how the paper was, what answers you have got. Okay, so it is supposed to have infinite number of solutions. It is supposed to have infinite number of solutions. Okay, let's take up a next question, dear, here. Okay. Right. A question coming up on directional derivative. Okay. The question is, what is the rate of change of the real valued function? I'll write down in brief. Rate of change of the real valued function, okay, that is v, which is equal to x square plus x, okay, plus y square plus 1, x square plus x plus y square plus 1 at origin in the direction of the point, in the direction of the point 1, 2 is. Okay. Now, doubly students, you can put this question in mathematics, you can consider this question in EMF, that's okay. Both the places you cover it, directional derivative. Okay, dear, so let's do it. Let's do this completely. Okay, so rate of change, the directional derivative, we need the gradient, number one. Okay, we need the gradient calculation, and what is the grad of v? Okay, let me start with the gradient of v, and that's going to be how much? I. Okay, partial derivative with x looks like 2x plus 1. Okay, plus j cap, partial derivative with y will be 2y, and it's only in 2D. Okay, so there is no del by del z term here. Okay, now at the origin, okay, the rate of change is required at the origin, and this looks like I. Okay, 2 into 0 plus 1, that is I into 1 cap plus j into 0 cap. Okay, so the gradient value is only I cap here. Okay, at the origin in the direction of the point 1, 2. Okay, so what is the direction vector? What is the direction vector that you are going to consider here? Okay, the value required at this point, moving along which line? Moving towards the point 1, 2, some point 1, 2. Okay, so let's say this is some direction vector A, for example. Okay, so this direction vector A is I plus 2j. Okay, from origin to 1, 2, this is I plus 2j. Okay, so dear, if this is I plus 2j, okay, what is the formula for directional derivative? It is equal to the gradient of the given scalar function at the point P. Let's say this is my point P, dot A hat, dot unit vector along this direction. Okay, so the gradient is simply I cap, dot I plus 2j, divided by the magnitude of this vector, which is root over 1 square plus 2 square. Only corresponding I dot I component multiply. So answer should be 1 by root 5. Let me check whether there are options or this is NAT. Whether there are options or NAT. So let me check that. Okay. Right. So let me check. Where is that question gone with me? Yeah, I think it's a NAT question. I think it's a NAT question as far as the data I have got. Guys, you can comment. Okay, then it looks like 1 by root 5. The final value you can calculate. Yes, dear, the final value you can calculate, and let me know, is this correct one? Okay. Okay. Yeah, we will go to that, Gaurav. I was just confirming whether the options are okay, whether we need to think it the Kylie Hamilton or whether we need to take the, any other route. Okay. We will come back to it. Yes, guys. NAT. Vira says this question is NAT. Okay. Yes, guys. So 1 upon root 5 you can calculate. Yeah, I think 1 upon, I think 0.44 looks like a justified value. Somewhere approximately like that will come. Rajiv says that. Okay, dear. Let's move ahead to the next question then. Okay, let's move ahead to the next question. What is the next question I have? Yeah. Yes, guys. There is a question of signals here in front of me. Okay, let's go to that question. Okay. Let's go to that question. Okay, so what is that, dear? Consider a discrete time linear. Okay, so let me write down the data here. Okay, consider a discrete time LTI system. Okay, so they have given some LTI DT system. Okay, such that y of n equal to s of x of n. Where s is the system, they have defined the system as s. Okay, such that, okay, now they have given an operation s. Okay, let yn is some function of input. Now let s of del n, where del n is the unit impulse. Okay, del n is the dt unit impulse function, they have given it. So let s of del n, okay, that is equal to 1 for n is equal to 0, 1 and 2. For n equal to 0, 1, 2 and 0 otherwise. It's purely conceptual. It's easy and conceptual. It's not direct, but it's conceptual, because when they say output is s of xn, xn is the input. So when you make the input as del n, we know that the response of LTI system when the input is unit impulse signal is known as the impulse response. That should immediately strike. That is known as the impulse response. So what is this actually given to you is nothing but the impulse response Hn of the system. Let me call it as impulse response Hn. Okay, so what can I say? What is the impulse response Hn? Hn equal to 1 for n equal to 0, 1, 2. For n is equal to 0, 1, 2, or I can say like this. Okay, the Hn, okay, because it has only 3 samples, 1 at origin. Okay, any dt signal can be represented as linear combination of impulses. Next impulse at n equal to 1, next impulse at n equal to 2, all of them are having the amplitude 1. Okay, so my impulse response is basically del n plus del n minus 1 plus del n minus 2. Okay, now dear, what are the options? Now, what are the options? For the input signal xn, what is the output yn? Okay, for the input signal xn, what is the output yn? Okay, so here I start the options now. Here I start the options now. Okay, what is the output yn? Okay, output yn is x of n plus 1 plus, I think it's not required to write down the option. Just to complete the question I am writing, by the Hn you can guess what is the IO relationship. Okay, option number B, xn, okay, plus x of n minus 1 plus x of n minus 2. Okay, option number C, x of n plus x of n plus 1 plus x of n plus 2, and option number D is equal to x of n minus of 1 plus of xn plus of xn plus 1 plus of xn plus 1. Okay, dear? Yeah, that is what it is. Okay, so Hn is del n plus del n minus 1 plus del n minus 2. So what is the output yn? Yn is nothing but the input xn convolution with Hn. Okay, so xn convolution del n will be xn. Next part will be xn convolution del n minus 1 is xn minus 1. And the last one will be x of n minus 2. Okay, and hence the option that is totally correct is the answer number B. The answer that is totally correct is answer number B. Right? Yes. The answer that is totally correct is the answer number B. Correct, dear? Correct? Yes. Sir? Okay, I'll check. You have any machines question till that?
Yes.
So by that time you can come?
You can, sir, I will just segregate the notes.
Okay. Let me find the others. Okay. This is the same question we have solved. Okay, so yeah, I have got one more mathematics question here, simple one only. Okay, that's a simple one. Let me write down this one. Let me write down this question. Okay, so what is that? Let V1 and V2, let the V1 and V2 are eigenvectors. V1 and V2 are the eigenvectors. Okay, corresponding to, important one, eigenvectors corresponding to distinct eigenvalues corresponding to the distinct eigenvalues of a 3 cross 3. 3 cross 3. What is that 3 cross 3 matrix? Real symmetric matrix. Okay, a 3 cross 3 real symmetric matrix. 3 cross 3 real symmetric matrix. Okay. Find the correct statement. Find a correct statement. Okay. So dear, without looking into the options, you can say that, na? Okay, if the eigenvectors for a real symmetric matrix corresponding to distinct eigenvalues are orthogonal to each other. Okay, are orthogonal to each other. Okay, now I'll write down the option. Now I'll write down the option. You can say what is the correct one. Statement I have told you, the property statement I have told you anyways. Okay, the next one is V1 transpose V2 not equal to 0, and option number D, V1 plus of V2 equal to the 0. Yes, dear. Yes, dear. Let me see what have you answered. What have you answered? Yes, anybody? Okay. No, Shekhar. See, x plus y equal to 0.5, that is correct, but that is a set of stationary points. That is a set of stationary points. For previous question you are telling, na? Correct. I told you, na, stationary points will be infinite. Okay, but they are asking the points which will minimize the function. So for the correct maxima or minima, you have to go to the second derivative, na, r, s and t. Rt minus s square is 0, entirely 0. Okay, well, any maxima or minima will occur if Rt minus s square is positive. Na? So you look into that part also. Okay, you look into that part also. Yes, Anay and Ajay Singh correct. It is A. Mantri also correct. It's A. The eigenvectors corresponding to distinct eigenvalues are orthogonal to each other. Okay, corresponding to distinct eigenvalues, V1 should be orthogonal or perpendicular to the V2. It should be perpendicular to the V2, and hence I can say that V1 transpose V2, okay, is equal to 0. Option number A is correct one. Option number A is correct. Okay. Let me check up any other question. Okay, let me check up any other question. Yes, dear. Just a second. Okay. Just a second. What is that? Okay, so basic question is there with respect to the impulse signal. With respect to the impulse signal, one more signals question, dear. Signal and system. So there is a CT signal. There is a continuous time signal xt given to you, and that is equal to minus of t square. Okay, minus of t square u of t plus 4 minus u of t minus 4. U of t plus 4 minus u of t minus 4, where ut is the continuous time unit step function. Let del t be the continuous time unit impulse function. What is the value of? What is the value of integral minus infinite to infinite xt delta t plus 3? Xt delta t plus 3 dt. Xt delta t plus 3 dt, and the options are minus 3, minus 9, 9 and 3. Okay, so what are these? What is this equal to, dear? What is this equal to? Integral xt delta t plus 3, and limits are full. So of course, impulse is within the limits of integral. So it is equivalent to x of minus 3. Now, the xt given to you is minus of t square ut plus 4. Now, ut plus 4 minus ut minus 4 will form a rectangular window. That means a signal starting from minus 4 going up to the plus 4. So I can say that the signal is minus t square from minus 4 to 4. Okay, and I want the value of the signal at minus 3. I want the value of the signal at minus 3. Okay, so the answer is x of minus 3, and at minus 3, any value minus 4 to 4, it satisfies the relation minus of t square. So minus of minus 3 square minus 9. Okay, minus 9, option number B, I will tick mark. Okay, I think it should be 1 mark. Yes, it is actually 1 mark MCQ question. It is very fundamental only. It is deserved to be 1 mark only. Okay, what is next? What is the next one? Okay. Yes. All right, a question on periodic signal and okay, average power of a periodic signal. It's on the average power of the periodic signal. So there is a continuous time signal. Okay, there is a continuous time periodic signal xt, which is equal to 1 plus 2 cos 2 pi t, 2 cos 2 pi t, 2 cos 4 pi t. Now see how the frequencies are arranged. 2 cos 4 pi t and 2 cos 6 pi t. 2 cos of 6 pi t, right? 2 cos of 6 pi t. Is that correct? Okay. Is that correct, dear? Okay, these are what the frequencies given. If t is the time period of the signal, and the answer, the value is 1 upon t. Okay, integral 0 to t. Time period you can guess. Okay, these are nothing but different harmonics given. Okay, the fundamental frequency 2 pi, then second, you can call it as the second harmonic, and you can call this as the third harmonic. Clear? Second harmonic and third harmonic. So the fundamental frequency is omega naught, which is equal to 2 pi. Time period is 1. Okay, anyways, that is not required. The question is 1 upon t integral 0 to t. That is integral over 1 time period mod of xt square dt equal to mod of xt square dt equal to what should be this value? Yeah, for the previous one, Ananya and Anaya Reddy, correct, -9 is the answer. Okay, that was a fundamental one. So basically, what is this, dear? What is this? This is the average power. What they are trying to ask is simply the average power of the signal. Yes, guys, I think this is also NAT. Yeah, this is also NAT. Okay, right. So tell me the correct answer. Okay, tell me the correct answer. Okay, so see, because they are just harmonic components, so what is the average power, dear? Okay, what is that average power? Okay, the first one is DC. We can call it as only once. For A, it will be called power as A square. But for any sinusoid, it can be written as A square by 2. And because they are harmonics, you can directly write the power as accumulation of all of them. Okay, if they were, not the harmonics, then of course we have the different methods. Okay, so power then accordingly turns out to be 2 square by 2 is 2. Okay, 2 and 2 plus 1, 7. Okay, 7. The answer, that is just 7. Okay, right. Since they are harmonics. Otherwise, you can think with respect to, this is indirectly Parseval's application only. Parseval's application for the power signal. Parseval's application for the power signal. Right. Okay. Okay, another question I have. All right, a 2 marks questions of signal. Yes, dear. A 2 marks question of signal. Let me see what is the answer students are giving for the previous one. Okay, correct. Now I open the chat box. Vignesh, Mantri, Durga, Anay Reddy, correct. 7 is the very correct answer. 7 is the very correct answer. Yeah, Veera, it was NAT question. Very correct. Okay, yeah. Moving ahead to the next question that I have got. Okay, moving ahead to the next question I have got. Okay, so an ideal low pass filter has the frequency response. Okay, so what is given to you? It is an ideal low pass filter. Okay, having what frequency response? H of j omega equal to 1. Ideal gain 1 is given for modulus of omega less than equal to 200 pi. So dear, automatically, blindly you can say that, okay, that the cutoff frequency of the filter then becomes the 200 pi. The cutoff frequency then becomes how much? 200 pi. Let ht be the time domain representation. What is the value of h naught? Okay, let ht be the time domain representation. Okay, so what is the value of h naught? So ht be the time domain representation means ht is the impulse response. What is the value of h0? What is the value of h0? Okay, see dear, even if I don't mention whether this is an ideal low pass filter or not, okay, if I just, we know that ideal low pass filter, also known as rectangular filter. So even if you plot this now, okay, it is some rectangular function, okay, from minus 200 pi, okay, up to 200 pi, and as I told you, this becomes the omega c. In that case, gain is 1. Okay, so what is the h of j omega or h of omega? H of omega is a rectangular function. Rect of omega by how much? Rect of omega upon 400 pi. The total width of the rectangle 400 pi. Okay, and then we can use a basic, one of the very, very common Fourier transform pair, sampling AT function, because rectangle is the Fourier transform corresponding to sampling. Okay, so sampling AT will have the Fourier transform pi by a rect of omega by 2a. Okay, so if you want omega by 400 pi, okay, so you should be taking sampling 400 pi t. Sampling 400 pi t, but will have the transform pi by, see, A I am taking 400 pi. Sorry, A I will take 200 pi. 2A is 4. So pi will get cancelled 200. Okay, so corresponding to this here, what is the HT? The, the inverse transform. So 200 you shift on the other side. It is 200 sampling 200 pi t. 200 sampling 200 pi t. What is the value of H0? The value of H0 is 200 into sampling 0. Sampling 0, you must know that will have the value of 1. Sampling 0 will have the value of 1. Okay, sine 0 by 0 primarily. Correct. So answer is 200. Simple. The answer is very, very simple. 200. Okay. Right. Or you can either, calculate H0 by area under the curve anyways, but this is a very commonly known transform. Okay, it's a very commonly known transform. Right. So, yes, sir. Where? No problem. I'll again come. I think some more control will also be there. I'll check if control is also there. Okay, sir. You can carry on. Yes, dear. So I think some around 8 to 10 question of mathematics and signals, 4, 5 from signals, I think 4, 5 from mathematics. So as of the questions we have got till now for mathematics and signals, it's moderate, easy to moderate. Okay. It's not difficult as of now from the maths and signals. Okay. From the maths and signals, right? Yes. So now some machine subjects, machine question there with Surendra Reddy, sir. Okay, and then I'll figure out if there are some more questions of signals, maths, even controls I'll see, and then we'll discuss those questions. Sir. Yes, dear. So how you felt about the machines? How you felt for the machines? Now Surendra sir is going to discuss the electrical machines question.
Very good evening to everybody. I hope your exam went really well. So I also wrote the exam just now. Right. So I hope I am audible now. So very good evening to everybody. Yes, I hope your exam went really well. I also wrote the examination and just came out from the examination. Yes. Electrical machines. So total 9 marks weightage. Okay. So we got 3 questions which are of 1 mark and 3 questions which are of 2 marks. Okay. Overall 9 marks weightage is there. There is one more question from the power factor correction of induction motor, but rather I must say that is like power systems question. Okay. You can even solve with the knowledge of power electrical machines also. If you include that question also, you can say it was around 11 marks, but rather I must say that is a more like power systems question, power factor control techniques. Okay. Now I will try to solve the questions which I remembered, the memory based questions. Okay. All right. So just a moment. Okay, so look at the first question. This is a question from DC machine. I must say this is a speed control of DC motors. You can read the problem. A DC series motor for which armature resistance is already 0. Okay, armature resistance is 0. Just a moment. Yeah. Driving a load torque proportional to cube of the speed. Okay, the torque is proportional to cube of the speed. Terminal voltage was 400 volt. Armature current was 40 ampere. Find what is the external resistance required to reduce the speed of the motor to half. Okay, so here we wanted to reduce the speed to half. So the first case is when machine was rotating at some finite speed, and the second case is add some external resistance in series to reduce the speed to half of the rated value. Okay, so let us take case number 1 now. Okay, case number 1. So in case number 1, the terminal voltage of the motor was equal to 400 volt. Armature current drawn by the motor was 40 ampere. There is no resistance to motor. The resistance of the motor is already neglected. and assume the speed of the motor in the first case is omega radian per second or n rpm. See, as there was no resistance internal to the machine, I must say back EMF of the motor, which is equal to Vt minus Ia into total resistance of the machine, that is equal to 400 minus 40 ampere into zero resistance. That's why the back EMF is equal to 400 volt. This is the first case. Okay. Now moving on to the next case, what happened? Additional resistance is added. Case number 2. So external resistance is added in series with the machine so that the speed of the motor was reduced to half of the previous value. The speed is reduced to half. And the given condition is torque is proportional to cube of the speed. Yes, we know in series motor, the torque formula is Ka phi into Ia. It is clearly mentioned in the problem that magnetic saturation is neglected. Therefore, flux is proportional to armature current and torque is proportional to Ia square. Yes, we are known about this, right? In series motor, torque is proportional to square of the current. According to this relation, torque is proportional to cube of the speed. So if I relate both of them, I can say torque is, cube of the speed is directly proportional to square of the current, right? Cube of the speed, square of the current, both are proportional to torque. So from this, omega 1 by omega 2 whole cube is equal to Ia 1 by Ia 2 whole square. Okay. What is omega 2? Omega 2 is half of omega 1. So overall it will become 2 cube. Okay. Is equal to Ia 1 40 ampere. Ia 2 is unknown value. That is what we need to calculate. So if I cross multiply, I can say Ia 2 will be equal to, it is 2 cube means 8, right? So therefore, it is 40 into root 8 ampere. So I hope, please solve and let me know in the options in the chat box. I'll bring my calculator, just a minute. Keep on responding in your chat box, whatever the answers you have. Okay, so let me see. 40 into root 8. So I should not say, it is not 40 into root 8, guys. It is 40 by root 8, correct? If I cross multiply, yes, 40 by root 8. So 40 by root 8. So it was 14.14 ampere. That is the new armature current. The moment I got new armature current, I can find out the new back EMF, right? So therefore, what is the formula for back EMF? There are two formulas. One is Ka phi into omega. Flux is proportional to armature current in series motor. So back EMF is proportional to armature current into speed. So first case back EMF divided by second case back EMF is equal to first case current divided by second case current into first case speed divided by second case speed. What is the back EMF in the first case? 400. Divided by what is the back EMF in the second case? We don't know. What is armature current in the first case? 40 ampere. And what is armature current in the second case? 14.14 ampere. Into omega 1, and omega 2 is half of omega 1. And omega 1 will cancel. So you can find out the unknown value, which is the new back EMF, right? So yes, if I cross multiply 400 into 14.14, okay, divided by 80. So I'm getting the new back EMF, which is 70.7 volt. But the answer required is what is the additional resistance added. So now use the KVL equation. What is the KVL equation for the new back EMF? The new back EMF EB2 is equal to Vt minus Ia2 into machine resistance plus extra resistance. Okay. Now new back EMF is 70.1 volt. Is it the answer? Yes, 70.7 now. 70.7. Vt was not changing, 400 minus 14.14. Machine resistance is neglected and the extra resistance is the answer we have to find. So find out what is the extra resistance value. Yes, 14.14. I am getting 23.28 ohm. 23.28 ohm. That is the additional resistance required so that you can reduce the speed of the motor to half of the previous value. That is option D in my question, 23.28 ohm. Okay, very simple question given for 2 marks. Okay, right. Okay, let me check anybody posting the answers here. Yes, 23 point. Nagendra, your answer is correct. Your answer is correct. Okay. Yes, Nagendra, my PYQ sessions are very helpful. Thank you so much. Hope you answered questions really well, right? Okay. So this is the extra resistance required. Okay. Now let's go through one more question. Okay. This is a 1 mark question and it is also a very easy question, I must say. Just to read the problem. The induced EMF in 3.3 kV 4-pole 3-phase Y connected synchronous motor, Y connected means star connected synchronous motor, considered to be equal and in phase with the terminal voltage. Please excuse my handwriting, okay, because I was in a hurry to gather the questions. Okay, and what is happening now? The load is connected and EMF is departed by 2 degrees. Okay, we know that the moment you connect the load, machine will decelerate and induced EMF starts lagging the terminal voltage. So indirectly this 2 degrees is nothing but load angle delta. Okay. Now what is the value of armature current in the question? So problem is simple. Initially the machine is under no load condition. Okay. So initially the motor, given question is a synchronous motor. It is a synchronous motor, guys. Okay. So the motor is under no load condition initially. In this condition, the induced EMF magnitude is exactly equal to terminal voltage. That was the given data. And this is nothing but 3300 by root 3 volt per phase. Because 3300 was the line voltage. Okay. 3.3 kV, that is 3300. Then the phase voltage will be 3300 by root 3. Both voltages are equal in magnitude. This is a no load condition, and in this condition armature current was 0. Clear? Now the load is connected. Second case. Now the machine is loaded so that EF lags VT by 2 degrees. Okay, that means indirectly this 2 is nothing but delta, load angle delta. Therefore we are asked to find out what is the value of armature current. Got it? What is the value of armature current? So what I need to do here, first of all, magnitude of VT and EF does not change. VT is equal to 3300 by root 3 voltage per phase, and you assume this is the reference phasor at an angle 0, voltage per phase. Now EF is lagging this VT by 2 degrees according to the given question, just 2 degrees. Okay, so what is the value of armature current is the question. In 2 ways you can answer the problem. Okay, one is by applying the KVL equation, another one is through normal simple equations. Okay, see that what is the equivalent circuit of synchronous motor. For synchronous motor, just a moment guys. Sir, is this background fine? I think pages are over, so is it fine? Otherwise I'll change it. Okay, okay.
You have seen when I was taking?
Yes. So
then I use the same.
Okay, I'll modify it anyway. Okay, anyway. So now if you come to synchronous motor equivalent circuit, this is the induced EMF lagging the terminal voltage by an angle delta. This is a synchronous reactance because resistance was anyway neglected. And here we have the terminal voltage. Terminal voltage is at an angle 0. So we are asked to find out what is armature current. I can simply write armature current is equal to VT minus EF divided by XS. Okay, you can write JXS or XS at an angle 90 degrees. Okay, so VT was 3300 by root 3 at an angle 0 minus EF is also 3300 by root 3 at an angle minus 2 degrees divided by synchronous reactance was 2 ohm, I think. Yes, synchronous reactance was 2 ohm. I did not write that, but it is given 2 ohm, I think. Okay. Yes, it's just a memory based. I didn't remember the reactance exactly. I thought it is 2 ohm. So this way you can directly find out the synchronous, armature current drawn by the motor. But solving this particular method is difficult in the examination hall because a complex calculation is involved. That is why the simplest way to solve the problem is without involving these complex calculations. Okay, I'll tell you what you do is that using this information, calculate active power and reactive power of the motor. What is the formula for active power? Active power is 3 EF VT by XS into sine delta. So 3 into what is EF? 3300 by root 3. What is VT? 3300 by root 3 because both are equal in magnitude, divided by XS is 2 ohm. Sine delta was 2 degrees. Okay. Please, I did not remember XS value correctly. I thought it is 2 ohm. In case if it is a different value, please follow the procedure. Okay. Now, anyway, here what happens? This root 3 and 3 will cancel. So finally, the solution becomes 3300 square by 2 into sine 2 degrees. Okay. Yes. So if I solve it, 3300 square by 2 into sine 2 degrees. So I'm getting 190027 watt. This is active power value. Now calculate the reactive power also in a similar manner. Calculate the reactive power as well. What is the formula for reactive power when RA is neglected? 3 VT by XS into VT minus EF cos delta. Suppose if it is alternator, it would have been EF cos delta minus VT, but it is motor. So once again, 3 into VT 3300 by root 3 by XS was 2 ohm. VT again 3300 by root 3 minus 3300 by root 3 into cos delta is 2 degrees. Okay. Solving this, you will get reactive power. You can take this 1 by root 3 common. Then what happens? Root 3 and 3 will cancel. So it will become 3300 by 2 into 3300 minus 3300 into cos 2 degrees. Okay. You can even take 3300 also common. Let me solve it. 2 cos so I'm getting 3316.94 volt ampere reactive. Please let me please correct me if I made any calculation mistakes. Okay. So please continue your calculations and respond in the chat box so that we will understand is there there are any calculation mistakes. Okay. So this is the reactive power. Now I have active power with me and also reactive power with me. So what I can do, I can calculate power factor, right? Because what is the formula for power factor when you know active and reactive power? Power factor formula will be equal to P by root over P square plus Q square. So active power P we got 190027 by 190027 square plus reactive power value was 3316 square. So this will give you power factor. The moment you got power factor, you can find out armature current. Okay, so let me solve it. So 190027 square plus 3316 square under root by, yes, it is almost 0.999 lagging, almost unity power factor. Okay. So this is a power factor. The moment you know power factor, you can find out what is the armature current just by using active power formula. What is active power? Root 3 VL IL cos phi, right? So active power 190027 is equal to root 3, line voltage 3300, line current we don't know, but the power factor 0.999. So this will give you the current drawn by the motor. Directly you can find the answer. 190027 divided by root 3 divided by 3300 by 0.999. So I'm getting 33.27 ampere. This is the line current, and that is also equal to phase current since the machine is a star connected machine. Okay, a very simple question. So it was very clear. EF and VT both are equal in magnitude at the time of no load condition. Later, EF is lagging VT by 2 degrees. So you can directly find, in case if you have a complex mode calculator, you can directly find out the answer using this calculation, but I hope this is a little difficult calculation. Okay, so you better proceed this way. Active power you find out, reactive power you find out, power factor. From that you can find out the current drawn by the motor. Okay, yes. So let's move to the next problem. Okay, so this is another 2 marks question, multiple choice question. This is a question from induction motors. You can see the problem. A 3-phase 400 volt 4 pole 50 Hz star connected induction motor has the following parameters referred to stator. You can see this is the rotor resistance referred to stator 1 ohm. Stator reactance and rotor reactance all are referred to stator. Important thing, stator resistance is neglected. Now machine is operating with constant V by F control method. For maximum starting torque, what are the values of voltage and frequency? Okay, so if I draw the equivalent circuit of induction motor, okay, so this is stator resistance, stator leakage reactance, rotor leakage reactance referred to stator, and rotor resistance referred to stator, and slip equal to 1. Why? Because our condition is maximum torque at the time of starting. We know at starting, actually this is R2 by S if you wanted to write. Okay, this is the supply voltage V1. Okay, but here R1 is neglected, this is 0. Therefore only reactances are available. Each reactance value is equal to 2 ohm, and this resistance value was equal to 1 ohm. Now the point is, in the rated condition, voltage was 400 volt and frequency was 50 Hz. These are the rated data or rated details. Okay, 400 volt and 50 Hz. Fine. Now our aim is to achieve maximum torque at the time of starting. Okay, we know at starting means slip equal to 1. What is the condition for maximum torque? This air gap power resistance should be equal to the series impedance, right? Okay, for that purpose, what is the voltage and frequency required? Okay, yes, see that. Condition for maximum torque at starting. Yes, what is the condition? For maximum torque at starting, SMT must be equal to 1. What is the formula for SMT? SMT is equal to simply R2 by not only X2, it is X2 plus X1. Suppose if stator reactance is neglected, then the formula will be R2 by X2 only. But here stator reactance is also joined, therefore it is X1 plus X2 dash. Correct or not? Okay, I must say it is X1 plus X2 dash. Correct? Now what is SMT is equal to 1. Resistance is 1 ohm. So these are the modified reactance values. If you use original reactance values, what are the original reactance values? 2 ohm plus 2 ohm. 2 plus 2 is equal to 4. But 1 by 4 cannot be equal to 1. That means what? We need to modify the reactance value. How to modify reactance value? By changing frequency. Therefore, according to this, I must say, Hemant, so now from this, I must say X1 plus X2 dash must be equal to 1 ohm. These are the new values. Okay. How to change the reactance values? By changing frequency. Suppose if you use rated frequency, what is X1 plus X2? 4 ohm. But now X1 plus X2 must be 1 ohm. 4 ohm value must be changed to 1 ohm. That means, can I say frequency must be divided by 4? If you divide frequency by 4, then only 4 ohm reactance will become 1 ohm reactance. Therefore, I must say the new frequency was 1 by 4 times of rated frequency. What is the rated frequency? 50. What is 1 by 4 into 50? 12.5 Hz. This is exactly same to previous gate question. Okay, a similar model was there in one of the previous gate exam as well. Okay, this is a new frequency. Then what about new voltage? Yes, it was given clearly constant V by F control method. Okay, constant V by F control method means rated condition V by F ratio must be equal to new V by F ratio. What is the rated voltage? 400, rated frequency 50. The new voltage I don't know, but new frequency was 12.5. So from this, I must say the new voltage will become 100 volt. That is the new voltage and this is the new frequency. Why we need to change frequency? To make SMT equal to 1. What is this SMT equal to 1? That is a condition for maximum starting torque. Okay, and the formula for SMT is R2 by X2. Suppose if X1 is neglected, but here X1 is also considered, so it is R2 by X1 plus X2, and this reactance should be a new value. Because if you use normal rated reactances, you don't get SMT equal to 1. You don't get a maximum torque at starting. Okay, yes, simple problem. So the new frequency was 12.5 and the new voltage was 100 volt. Clear? Okay. Let us try to answer one more question. Okay, this is a 2 marks question. Let me go through the charts. Are you finding the answers? Yes. Come on, please solve using your calculators, respond with your answers. Right. Okay. Now let's try to answer one more question. This is a 2 marks question. This is a question from transformers. Okay. So let me enlarge it. Okay. Yes, it was a star delta connected transformer given for us. Phase sequence was ABC, that was clearly mentioned in the problem. Okay. The turns ratio was given. Phase sequence is ABC. The turns ratio was 2:1. We know turns ratio is always phase ratio. IA plus IB plus IC is equal to 0. See, secondary side, this is IA, this is IB, this is IC. I'll draw a new diagram, enlarged diagram. Then what is the relationship between primary line current capital IA and secondary line current IAD? That is the question. So I will try to redraw the diagram so that it will be easy for you. Okay. So this is the star connection stator. Sorry, not stator, primary. Okay, this is a star connected primary. So this is line A, this is line B, and this is line C. Line A current was given as IA, line B current IB, line C current IC. Coming to the secondary, secondary is a delta. This is how the delta was given. This is a terminal A, this is a terminal B, and this is a terminal C. This is given as phase A current IA. This is IB. I think this is IC. Now this is the current IAD. Okay. Now what is answer? What is the question asking? They are asking the relation from primary line A current to secondary line A current, and the turns ratio was 2:1. 2:1. Yes, we know turns ratio is nothing but a phase ratio always. That means N1 by N2 is equal to 2 by 1. So N1 by N2 is equal to 2 by 1. We know N1 by N2 is equal to I1 by I2 or I2 by I1. I2 by I1, right? What is mean by I2? Secondary phase current. I1 primary phase current. Let us see phase A. You compare any phase, I am comparing phase A. What is secondary phase A current? IA. What is primary phase A current? Is it not capital IA? Therefore, this 2 by 1 is equal to secondary phase current small ia by primary phase current capital IA. And if you cross multiply, secondary phase current is equal to 2 times of primary phase A current. Correct? But now secondary side, it was given very clearly in the problem. You please read the problem. IA plus IB plus IC is equal to 0. That means what? The angle among these 3 currents is equal to 120 degrees, right? Suppose if you assume IA at an angle 0, then IB definitely at an angle minus 120, IC is definitely at an angle plus 120. Then only the summation will be equal to 0. Okay. Therefore, this secondary phase A current is at an angle 0. If a secondary phase A current is at an angle 0, then what about the primary phase A current? It is 1 by 2 times of IA at an angle 0. Therefore, primary phase A current is also at an angle 0. But what about secondary line current now? Line current IAD. You apply the KCL equation at this node. Okay. See, this current is going in upward direction. This current is going in downward direction. So currents going towards the node is equal to currents leaving the node. So therefore, yes, secondary phase A current is equal to leaving currents IAD and IC. IAD plus IC. From that IAD is equal to IA minus IC. What is IA? It is simply, let us say, I at an angle 0. Okay. Then what about IC? All are equal in magnitude, right? What is IC? I at an angle plus 120. Okay. So you can take I common. This is 1 at an angle 0 minus 1 at an angle 120. Yes or not? Therefore, you will get, what is the sum of these two? 1 at an angle 0, this can be written as plus 1 at an angle minus 60, correct? Isn't it? So what is the sum of these two? Root 3. Root 3 into I at an angle minus 30 degrees. This is a secondary line current. What about the primary line current? Primary line A current is equal to 1 by 2 into I at an angle 0. Secondary line current root 3 I at an angle minus 30. Therefore, the answer, primary line A current by secondary line A current is equal to, what is primary line A current? 1 by 2 I. 1 by 2 I at an angle 0 by secondary line A current is root 3 I at an angle minus 30. So therefore, final answer, I will cancel 1 by 2 root 3 at an angle plus 30. So magnitude wise, if you compare, 1 by 2 root 3 is the answer. But angle wise, I can say primary line A current is 1 by 2 root 3 times of secondary line A current. And it is at an angle 30. Got it? Okay. So therefore, what is the answer? Magnitude wise comparison is 1 by 2 root 3. And secondary line current lags the primary line current by 30, or primary line current leads the secondary line current by 30. Anything is correct. So IA leads IAD by 30 degrees, or IAD lags IA by 30 degrees. Okay, simple question. Okay, magnitude ratio 1 by 2 root 3, angle is IAD lags IA by 30 degrees. Okay. I think we are almost done. We have one more question. Okay, so this is a question where you need to have a bit of logic. You see that the developed torque and speed of an induction motor drive is given by a shaded region. I have not drawn the shaded region. This is the region. Okay, OQRS, and load torque is also given. What is the initial operating point is O, and what is the shortest region, region, you can say, what is the operating point path so that the motor can start very quickly. Okay, shortest time. So you see that I will go to the next page and I will redraw the diagram. So this is the electromagnetic torque and this is the speed omega. This is the load torque, guys. So this is the point O, this is point F, this is S, this is P. Above this P we have a Q and we have R here. Okay, and we have E. Okay, this is a drives question basically, but you can still answer it using electrical machines knowledge. You see, this is the load torque, guys. We all know that for a motor to accelerate, always electromagnetic torque should be more than load torque. Right? Electromagnetic torque should be more than load torque. If this is the load torque, therefore definitely this is not the zone. If you take electromagnetic torque below the load torque, motor cannot accelerate. So therefore, this should be the operating zone. But the point is, what is the operating zone where the motor will start very quickly? Okay, the answer will be O, P and S. Why I am not selecting Q and R? Because if you look at Q and R, both points are above the load torque, because the machine has to finally reach this point S, guys. According to the question, the final operating point is S. We know what is mean by final point, steady state. What is mean by steady state condition? Steady state condition means the condition where electromagnetic torque is equal to load torque. Am I right? That is why load torque will reach this S point. That means electromagnetic torque should also reach this S point. Okay, that's why I should avoid this R point. Electromagnetic torque should not reach R point. Why? Because if it really reaches R point, what happens? If the electromagnetic torque reaches this R point, so look at this. At this speed E, electromagnetic torque is at R, load torque is at S. Therefore, electromagnetic torque is more than load torque. That means the machine will not find steady state. It will further accelerate. But the final operating point is S only, right? That means when the speed reaches to this E point, both the electromagnetic torque and load torque should reach this point. That's why I have to select O, P, S. Only this zone I have to select. But the starting operating point is O and then P, S. This should be the operating point. So O, P, S. This is the electromagnetic torque zone. Then only the machine will stop at this final operating point. Otherwise, if in case it reaches to Q, R, S, R means electromagnetic torque is more than load torque. So machine will further accelerate. It will not stop at this point. Okay? Yes. So OPS is the correct answer. Right. So I think we are almost done. One more question. The last problem. Yes, it's a very simple question. Which instruments are used to synchronize an alternator with infinite bus bar? Yes, the straightforward answer, we need synchroscope and voltmeter according to the options available. What is the purpose of synchroscope? Synchroscope is used to measure the phase angle difference between bus bar voltage and alternator voltage, also to find out frequency difference between bus bar voltage and alternator voltage. And voltmeter we will use to measure the magnitude difference between bus bar voltage and alternator voltage. Remember, there are 4 conditions to be satisfied to synchronize an alternator with infinite bus bar. First rule is bus bar voltage and alternator voltage magnitudes must be same. B means bus bar, A means alternator. Second rule is frequency of bus bar and frequency of alternator must be same. Third rule is bus bar voltage phase angle and alternator voltage phase angle must be same. And fourth rule is phase sequence. Bus bar phase sequence and alternator phase sequence both must be equal. Then only perfect synchronization is possible. And you see, this condition you can check using the synchroscope. This condition we can check using the synchroscope. But remember, this condition you cannot check using synchroscope. Synchroscope cannot compare the magnitudes. It can only compare, phase angles and frequency. For this purpose, you need voltmeter. And for phase sequence matching, we will use 3 dark lamp method. But anyway, 3 dark lamp is not available in the options. So out of the options available, voltmeter and synchroscope is useful. Okay. You may have a doubt about stroboscope. Actually, stroboscope is a instrument which is used to measure the speed of apparatus, but it won't give you exact accurate answer, so we will avoid. Synchroscope is best compared to stroboscope. Okay, so synchroscope and voltmeter are the answers for these questions. Okay, that's all. So these are the questions we have from electrical machines subject. Okay, so any doubts, please let me know in the chat box. Okay, I'll try to give you the replies. Meanwhile, the next subject will start. Okay, come on guys, please let us know your answers in the chat box. Okay. Yes, next we have Gautam sir. Sir will start electrical circuits and analog electronics questions. Okay. So sir will start with analog electronics, and then sir will also discuss electrical circuits questions. Okay. Come on guys, please let us know your let us know about your opinion about the examination in the chat box. Also let us know your answers.
Good evening. I hope you have done decently well in the exam. So I'm here to discuss the questions from analog circuits. So in analog circuits, I could find altogether 4 questions, 2 from op-amp, another 2 from MOSFET. So let's look at the questions. So the first question is based on op-amp. So there is a circuit that goes like this. So this is the given op-amp circuit. So as you can see, there are 2 op-amps. Both the op-amps are ideal. And also there are 4 resistors. All 4 resistors are actually identical, it seems. Okay. So you have 2 ideal op-amps and also 4 identical resistors. And your input voltage is applied across these 2 points. Okay. So this terminal is marked plus and this side is marked minus. Okay. And at this output terminal of the second op-amp, we take the output voltage. I think the question is what? Find V0 by Vn. This is the question. This is fairly straightforward. So first of all, let me call this voltage, the voltage at this point as what V1, and let me call the voltage at this point as what V2. Okay. Now, if you look at the circuit, both the op-amps are clearly negative feedback. For this op-amp, output connected to what? Negative input terminal. Even for this op-amp, output connected to what? The same negative input terminal. So both the op-amps are in negative feedback. So ideal op-amp negative feedback, we just have to use the concept of virtual short. And because I called the voltages at these 2 points as what? V1 and V2, this Vn can be written as what? V1 minus V2. Okay. Now, if you look at this part of the circuit, yes, is it not a non-inverting amplifier? Of course, this voltage, the voltage here will be what? V2 from virtual short. You can write KCL here, but another way of doing it is what? Just to identify that this part of the circuit is what? A non-inverting amplifier, whose gain will be what? 1 plus R2 by R1. R2 by R1 is what? 1. 1 plus 1 is what? 2. So what would the voltage at this point be? 2 times the input to this non-inverting amplifier, which is V2. So it would be 2 times V2. Okay. All right. Then if you look at the remaining circuit, which is this part of the circuit, for this part of the circuit, it is as if 2 different inputs are applied at 2 different locations. Okay. This is one input 2V2 applied here. Another input V1 is applied here. You can use superposition. You can find what is the output due to this input alone. You can also try to find what is the output due to this input alone, and then you can add up the 2 outputs to get the net output. Otherwise, you can just apply virtual short, because this is V1, this would also be V1, and then this current and this current would be equal. You can write KCL and equate the 2 currents, and also you can get V0 in terms of V1 and V2. But I'll just directly do it by superposition. So assuming that only this 2V2 is there, meaning V1 becomes 0, which means this point would be shorted to ground. Then is it not the inverting amplifier? Yes or no? Plus terminal connected to ground, and then an input applied here, whose gain would be what? Minus R2 by R1, which is again minus 1. So due to 2V2 alone, the output will be what? Minus 2V2. And now what? We should try to find the output due to V1 alone. Okay. In this case, we'll assume 2V2 is going to become 0, which means this point you can just short it to ground because 2V2 becomes 0. Then V1 is going to be active. Okay. Now V1 is like the input applied at the plus input terminal. And if you look at this circuit now, when only V1 is present, does it not resemble a non-inverting amplifier whose gain would be what? 1 plus, R2 by R1, which is 1 plus 1, that is what? 2. So due to V1 alone, the output will be what? Plus 2 V1. That's all. So we have the output in terms of V1 and V2. But the goal is what? To find V0 by Vn. But we already know Vn is what? V1 minus V2. So whatever output we got is same as what? 2 times, V1 minus V2, which is nothing but 2 Vn. So the question is what? To find V0 by Vn. As you can see, the answer is what? 2. Okay, I don't know if it is a 1 mark question or a 2 mark question. So let's look at another question. There's one more op-amp circuit. That's all. That this is the given circuit. Again, as you can see, there are two op-amps. Both the op-amps are ideal. There is an MCQ, and it's a 1 mark question. Okay. So input is applied here, output is being taken at this point. Assuming ideal op-amps, the circuit represents there are 4 options. Okay. So the given circuit is going to be what? First option is it's a logarithmic amplifier. Can it be a logarithmic amplifier? For it to be a logarithmic amplifier, it has to employ at least one device that has an exponential relation between current and voltage. And what are the two elements that have an exponential relation between current and voltage? One is diode, the other one is what? BJT. But in this circuit, there is no diode, there is no BJT. So it's impossible for this circuit to be, what is that? Logarithmic amplifier. So this straight away can be ruled out. The other option is what? It's a difference amplifier. Again, it makes no sense because only one input is applied. Difference amplifier will amplify the difference between two applied inputs, but here there's only one input. So it cannot be a difference amplifier. Another is what? Summing amplifier. Again, summing amplifier also doesn't make sense because there's only one input. Okay. The last option is what? Buffer. It has to be a buffer. Okay. Because if you look at this part of the circuit alone, is it not the classic op-amp voltage buffer? Yes. And also both the op-amps will be in negative feedback. Okay. The loop gain, overall loop gain will be negative. So this Vin, or you can say this V0, will reach this point, and because this op-amp is also in negative feedback, due to virtual short, both the input terminals will be at same potential. So V0 becomes equal to what? Vin. So V0 equal to Vin, and also what would the input resistance be? It would be infinite because at the input terminal, the current drawn would be 0. So Rn tends to infinity. Well, if you also want to know what is the output resistance, see, the thing is, if at all you connect a load here, okay, 1 second. If you connect a load here, then the voltage across this load would become what V naught. That is the output voltage. So in this circuit, what happens is, whatever be the value of RL, whether it is 1 kilo ohm or 10 kilo ohm or 100 kilo ohm, always the load voltage or the output voltage will be equal to what? V in. Yes. In other words, the load voltage will be independent of the load resistance, and that will be only when the load is connected across what? Some type of ideal voltage source. So with respect to RL, the remaining circuit will behave like an ideal, voltage source. Ideal voltage source, the internal resistance is what? 0. So R out will also be 0. So for the circuit as a whole, the input resistance is what? Infinite. The output resistance is what? 0. And the voltage gain, AV, is what? 1. So voltage gain of 1, Rin of infinity, and R out of 0. These are the properties of a voltage buffer. Okay. I mean, this much of analysis is not required. I'm just trying to add a point or two. Okay. So let me find another question. Yeah. So the next question is based on mass cascade. Okay. This is also a 2-mark question, and it is an MCQ. So let me draw the circuit diagram. So first we have the supply VDD. After that we have a DC bias current source, which is IDC, followed by a stack of 2 MOSFETs. And this is the output terminal. And the 2 transistors are labeled M1 and M2. Now some data is given about this circuit. I'll quickly read it out. IDC, that is what this current source, it's an ideal current source. Okay, it is an ideal current source, which means during AC analysis, anyway, this will become open. I mean, if it is non-ideal, it would be having some internal resistance in parallel and so on. And during AC analysis, this RP would remain. Okay, but because it is ideal, that RP will be what? Infinity. So during AC analysis, this entire thing will become open. That is the thing. Okay. All right. And then Vin is what? The input. VDC. Obviously, it is what? DC voltage. Both M1 and M2, that is what these 2 NMOS transistors, have a small signal resistance of RDS. So what is that RDS? It is due to channel length modulation. It is like the output resistance of the transistor, or the small signal resistance between drain and source. Okay. So for both transistors, okay. So for both M1 and M2, that R0, it is the same, which is to say R01 equal to R02 equal to what? Some RDS. And also the transconductance GM also is going to be same for both the transistors. Okay. So it looks like both the transistors are identical. Okay. So GM is what? The transconductance of each transistor, and RDS is what? The value of R0 of each transistor. So this is the given thing. Now the question is, the small signal output impedance of the circuit is, okay. Small signal output impedance of the circuit is. So what do you mean by output impedance? Looking into the network at the output terminal, what is the equivalent resistance you are going to see? So if you are someone located at the output of this network, In how many ways you can look into this network? You can look up or you can look down. Okay, let's say looking up, you find an equivalent resistance of R1, and looking down, you find an equivalent resistance of R2. Then what is the net resistance seen by this guy who is looking into the circuit at its output terminal? R1 parallel R2. Okay, but what is R1? R1 is infinite. Okay, because the current source is what? Ideal. Had it been non-ideal, then R1 would be equal to what? The internal resistance of this current source. But because it is ideal, R1 is what? Infinity. Now the only thing that you have to find is what? R2. And what is R2? It is the equivalent resistance seen looking into the drain of M2. Okay, but if you notice, for M2, the source is not connected to ground. At the source, you have a transistor M1. Okay, so I mean, what is the systematic way of finding this output resistance? You have to draw the complete, small signal equivalent circuit, and then at the output terminal or at this node, you have to connect the test voltage source VT, and then you have to make everything else zero, meaning this VDC becomes zero, Vin becomes zero, and then you should try to find VT by IT. That is the standard way of doing this. But this is such a popular circuit that most of you who are aware of this should be knowing this value of R2, which is the equivalent resistance seen looking into the drain of M2. So let me write the corresponding small signal parameters as what? GM1 and RO1 for M1 and GM2 and RO2 for M2. So firstly, if you are here and if you look down, are you not looking down into the drain of M1 with its source grounded? Looking into drain with the source grounded, what do you find? R01. So what you can do is you can replace this M1 with a single resistance of value R01. Okay. So anyway, let me first write the options, then I'll get the answer and come back to the options. Okay. So the first option is infinite. It can't be infinity. It would be infinity only when R0 is what? Infinite for both transistors. Okay, but that is not the case. The second option is what? 2 RDS. Third option is GM RDS square plus 2 RDS. And D option is what? 1. I mean, it can't be 1. So correct option is what? Obviously C. Okay. కాపీ ఎలా చేయాలి ఇలాగా ఓకే ఇదా is what we have to find. Okay. So I told you what, you can replace this transistor with R01. Okay. Now M2, it is kind of like source degenerated by this resistance R01. And for M2 itself, the parameters are GM2 and RO2. So now R equivalent would be what? R01 plus R02 plus GM2 times R01 times R02. This is such a standard result that we have for any MOSFET which is source degenerated, meaning there is a resistance connected at the source and then you are looking into drain. That is the equivalent resistance you are going to see. Now in the question, it is given that R01 and R02 are identical and equal to what? RDS. So this becomes RDS, this also becomes RDS. So it will become 2 RDS, and the other term would become GM times RDS squared. And this is what? Option C. Okay. I think there's one last question. This is also an MCQ, and it's a 1-mark question. 4 statements are given. Which one of the following statements is true about the small signal voltage gain of a MOSFET based single stage amplifier? So instead of writing that entire statement, I'll simply write identify the correct statement. Identify the correct statement. The first statement is what? Common source and common gate amplifiers are both non-inverting amplifiers. CS means common source. CG means common gate. Common source and common gate amplifiers are both non-inverting amplifiers. That is one statement. Okay. Now, what does this phrase mean? Non-inverting amplifier means what? It's an amplifier that has a positive gain. So indirectly they are telling that the voltage gain, it is positive for both common source as well as common gate. It is incorrect statement because common source, always the voltage gain will be what? Negative. Okay. So statement A, straight away you can say it is what? Incorrect. The other statement is what? Common source is non-inverting and CG, that is common gate amplifier, is inverting. This again is an incorrect statement. Common source, just now I told you it has a negative gain. So common source is like an inverting amplifier. Common gate amplifier will always have a positive gain. So common gate has to be non-inverting type amplifier. Okay. So both A and B are incorrect statements. What is the next statement? Common source, that is CS, is inverting and CG, that is common gate, is non-inverting. This is correct. Okay. This is the correct option. So, I mean, once you come across this option, you don't even have to look at the next option. Okay. So let's see if I can find another question from analog circuits. I think that is it with regard to analog circuits. Now let's look at the questions from electric circuits or networks. Okay. So I'll just draw the circuit diagram and tell you what the question is, and then we'll try to answer the question. There's a simple circuit that is given. You have a 2 ohm resistor in series with an RL load. Okay, so this series combination of R and L is our load, and this entire network is being driven by, an AC voltage source whose value is what? 200 volts RMS. So what is the value of the source driving the circuit? It's a 200 volt AC source, and some voltage are also given. they are saying that the RMS voltage across the 2 ohm resistor is what? 9 volts. Okay. And then the RMS voltage across the load is what? The series combination of R and L, that is 199 volts. Okay. So at 199 volts is what? The RMS voltage across the entire load, and 9 volts is what? The RMS voltage across this 2 ohm resistor, and the source voltage is what? 200 volts RMS. Okay, this is the given circuit, and the question is what? To find the average power delivered to the load, or average power absorbed by the load. Okay, so find average power absorbed by the load. I mean, load has a resistive component in the form of R and a reactive component in the form of L. When it comes to average power absorption, you know, it's only R that will contribute to the answer we are looking for. Okay. So to find the average power absorbed by the load, you should simply find the average power absorbed by the resistor R. Okay. And to find the average power absorbed by the resistor R, you can try to find the RMS value of the current through this R, yes, and then square that RMS value of current and multiply it with R. But remember that R is not given, R is not known, L is also not known. Okay. Another thing that you could do is what? You can try to find the RMS voltage across the resistor. Okay. And then square of that RMS voltage across resistor divided by R will again give you answer. Another thing that you can do is what? For this resistor, you can try to find the RMS voltage and also the RMS current. Can't we directly find the RMS current? Because for this resistor, you notice for this resistor, already the voltage value is given. Okay, so assuming this loop current to be some I, yes, so what would this loop current be? It is same as the current flowing through this 2 ohm resistor. So 9 by 2 is what? 4.5 amps RMS. That is the RMS current flowing in this loop, and that same RMS current will also flow through what? The resistor. Now the only thing we need to find is what? The RMS voltage across the resistor. So what I am going to do, I will assume the phasor voltage across the resistor to be some VR, capital VR, and let's assume the phasor voltage across the inductor to be some capital VL. Now because sorry, because R and L are in series, they will obviously have the same current. Okay. Now for resistor, I and VR will be in phase, but for inductor, VL will lead I by 90 degrees, which means VL will lead VR by 90 degrees. Yes or no? So VL leads VR by 90 degrees. In other words, the two phasors VL and VR are going to be perpendicular to each other. Okay. So on the phasor diagram, if you try to show the two phasors, they will be perpendicular to each other. Okay. I mean, the relative angle between the two would be 90 degrees. Okay. So what would this 199 volt RMS be? So because we are trying to, I mean, this 199 volt RMS is what? The sum of these two voltages. Okay. I mean, the phasor summation of these two voltages. Okay. And because both are perpendicular, it is like finding the hypotenuse of a right triangle, okay, where the two perpendicular sides will have lengths of VR and VL. Then what would the hypotenuse be? It would be square root of VR square plus VL square, and this is how much? This is 199 volts, okay. And also, if you look at the overall circuit, I mean, you can write KVL around this loop, which will give you what? That this voltage plus this voltage plus this voltage is equal to what? The applied source voltage. Now, the voltage across the 2 ohm resistor and the voltage across this R, which is part of our load, will be in phase, okay, will be in phase because current is same, voltage also will be in phase, okay. That means 9 volt RMS and this VR will get add up, okay. So it is like this. VR plus 9. So why did I write VR plus 9? Because this and this volt, I mean these two voltages are going to be in phase, they'll be in same direction, and when you try to write KVL, both will get add up. Okay, so the summation of these two voltages, that is what VR plus 9, will be again perpendicular to what VL. Okay, so VR plus 9 will again be perpendicular to what VL. So once again you can imagine a right triangle where the two perpendicular sides are going to have lengths of VR plus 9 and VL, and then for this new right triangle the hypotenuse would be what, the source voltage, which is what, 200 volts. Okay, so just for your understanding, I'll drawn this right triangle. So one side, if it is VL, the other side is what, VR plus 9, and the hypotenuse is nothing but the source voltage, which is 200. Yes. So once again, we have that hypotenuse thing for the right triangle, which is square root of what is it, VR plus 9 whole square plus VL square equal to what, 200. Yes, that's all. So from these two equations, there is one equation, there is another equation, you can just eliminate VL and find VR. And that VR will be what? The RMS voltage across resistor. Already you know the RMS current through the resistor. Just multiply the RMS voltage and the RMS current. You will have the answer, which is the average power absorbed by the load. Okay. So if I have to solve it, all right. See this equation, if I just square it on both the sides, I'm going to get VR square plus VL square equal to what? 199 squared. Okay. And this other equation also, if I try to square it on both the sides, then I will get VR plus 9 whole square plus again VL square equal to what? 200 squared. Okay. Let me call this equation 1. Let me call this equation 2. I'll just subtract the first equation from the second equation. So when I subtract the first equation from the second equation, clearly VL square and VL square will get cancelled out. And then VR square also will get cancelled out. And then 200 square minus 199 square. It's like A square minus B square, which is A plus B into A minus B. 200 plus 199, which is 399, into 200 minus 199, which is what, 1. So right hand side is going to be what, 399. When you do 2 minus 1, it is going to be 18 VR plus 81 equal to what, 399. That's all. So from here you can get the value of VR. So what would VR be? 399 minus 81 divided by 18. So I'm getting this value, 17.67. What are the units going to be? Volts RMS. Because the given voltages are all in RMS terms. Whatever voltage you find will also be in RMS terms. That's all. The current is what, 4.5 amps RMS, and the voltage across resistor is what, 17.67 volts RMS. So what is the average power absorbed by the load? It is just VR, RMS into the RMS value of the loop current, which is 4.5 amps. Okay. So just multiply this voltage with 4.5. Okay. So I'm getting 79.5 watts. That is the average power, absorbed by this RL load. Okay. So that is one question that I could gather. All right, I found another question. There is a numerical answer type question and it's a 2-mark question. So some circuit diagram is given. So first you have a 100-volt source and then you have a 5 farad capacitor, and then there's again this 2 ohm resistor, and across these two terminals you have a switch, and that switch is what denoted by S. And across the switch you have a 25 ohm resistor in parallel with a 3 ampere current source. Okay, this is the given circuit, and then the switch is being closed at t equal to 0. So the switch is being closed at t equal to 0. The time in seconds at which the capacitor gets charged to 50 volts. Okay. So find time after t equal to 0, that is after closing the switch, at which cap voltage, meaning the voltage across the cap, becomes how much? 50 volts. I mean, there is a very typical problem in first order circuits. Okay, I mean it's a first order circuit. There's only one capacitor. So because the switch is being closed at t equal to 0, the circuit is not the same for t less than 0 and t greater than 0. So first you have to look at the circuit for t less than 0. Okay. So t less than 0, the switch is going to be open. Okay. So t less than 0, switch is going to be open. So here I'll just, sorry. So I've just opened the switch. When will this circuit start? This circuit will start at t equal to minus infinity. So at t equal to 0 minus, this circuit will reach steady state. Okay. So at t equal to 0 minus, circuit will reach steady state. Now for t less than 0, both the sources will drive the circuit and both are DC sources. So circuit will reach, DC steady state. And at DC steady state, the cap will become open and so on. So I'll just assume the cap to be open. And let me call the voltage across the cap to be some VC. Okay. Now we need to find the value of VC at t equal to 0 minus. Okay. Will any current flow in the switch? No, because switch is open. And also no current will flow in this branch because the cap becomes open at DC steady state, which means the current in this piece of wire would be 0. So this entire current will only flow through this 25 ohm resistor. Okay. And this drop would also be 0. So 3 amps flowing through 25 ohms. The voltage across 25 ohms will be 75 volts. Okay. And now what? You should try to write KVL around this loop. If you start at this point and write KVL around this loop, you will get, directly also you can write VC, but minus 100 plus VC plus 75 equal to what? 0. So what is VC? 25 volts. So what is this 25 volts? It is VC at 0 minus, and it is what? 25 volts. Okay. Now we need to draw the circuit for t greater than 0. Okay. So I'll try to erase everything that I just wrote. All right, now let's look at the circuit for t greater than 0. T greater than 0, the switch is going to be closed. So in place of the switch, I put a short circuit. Okay, this is a circuit for t greater than 0. So what is the initial voltage across the cap going to be for t greater than 0? Same as Vc of 0 minus, which is 25 volts. Okay, and what is the time constant of this circuit for t greater than 0? So while finding time constant, you just have to find the equivalent resistance across the capacitor, okay? And while finding the equivalent resistance across the cap, you have to make all sources 0, okay? So this current source will become open, but you know this 25 ohm resistor is across a short circuit. You can remove 25 ohm resistor as well. And this voltage source will become short. Then the only resistor that is going to be present across the cap is what? This 2 ohm resistor. So what is R equivalent across the cap? It is 2 ohms times the capacitance, which is 5 farad. 2 times 5 is what? 10. So tau, the time constant of this circuit is what? 10 seconds, okay? And this circuit again, after a long time, that is at t equal to infinity, will reach steady state. So Vc of infinity, that is at steady state. Again at steady state, you know, the cap will become open, okay? Again, when the cap becomes open, no current will flow, at least in this loop. So this 100 volt you know, potential difference will directly go and appear across this open circuit, okay? Because the drop across this would be 0, okay? So Vc of infinity is what? 100, that's all. We have the initial value of Vc as 25. We have the final value of Vc as what? 100. So what will Vc do for t greater than 0? Starting from 25, it will exponentially go up to what? 100, okay? And the question is what? At what instant Vc will reach 50? I mean, while going from 25 to 100, somewhere somewhere in between, Vc will definitely touch 50, okay? So we just have to write the expression for Vc of t. Final plus initial minus final. 100 plus initial is what? 25. Sorry. Minus final times e bar minus t by tau. In place of tau, I directly wrote 10. Now we are trying to find the time instant at which Vc becomes 50. So just equate this to what? 50. Okay, and then solve for t. That would be the answer. 25 minus 100 is what? Minus 75. Let's bring this term to this side. It will become plus 75 times e bar minus t by 10 equal to what? 100 minus 50, which is 50. So then e bar t by 10 is what? 75 by 50. 75 by 50 is what? 3 by 2, which is same as, sorry, 1.5. So now if you take, you know, ln on both the sides, t equal to what? 10 times ln 1.5. ln 1.5 into 10. I'm getting this value for t, 4.05 seconds, okay? So at this instant, the voltage across the cap will reach 50 volts, and after that it will continue to increase and ultimately reach 100 volts, okay? So let's look at another question. So I guess there is a third question. It is an MSQ and it is for 2 marks. 2 coupled coils with self-inductances L1 and L2. I'll just try to write the equation. 2 coupled coils with self-inductances L1 and L2 carry currents I1 and I2. That means current through L1 is I1, current through L2 is what? I2. The mutual inductance between the 2 coils is M. with unity coupling coefficient. So the coefficient of coupling is 1. M is what? K times square root, L1, L2. So M, because K is 1, M will be what? Square root of L1, L2. That is a mutual inductance in terms of the self-inductances. The stored energy of the pair of coils is minimum at which value of I1 by I2? The stored energy of the pair of coupled coils is minimum at what value of I1 by I2? That is the question. 4 different options are given: minus L2 by M, minus L1 by M, minus M by L1, and I guess the fourth option is minus M by L2. All right. So first of all, the circuit diagram is not given. So we don't know whether whether the, self-linkage and the mutual induced flux are going to reinforce each other, or they are going to be in opposite direction. Okay. So initially I'll go with the case where, the self-linkage and the mutual induced flux are both in the same direction. Okay. In that case, so in other words, I'm just considering the case where you have additive flux. Okay. So the overall flux in each coil will get increased due to the current flowing in the other coil. That is the case of additive flux. So in case of additive flux, what is the expression for the total energy stored in the pair of coils? I mean, with or without coupling, you have these two terms, right? Half L1 I1 square plus half L2 I2 square. Now, in case of additive flux, the third term is going to be plus M times I1 by I2. But if you consider opposing flux, okay, where the two fluxes will actually get subtracted from each other, then the last term would become negative, minus M times I1 by I2. But the first two terms will always be the same. Okay, this is the expression for the energy stored in the pair of coils when you have additive flux. Now, according to the question, this total energy stored in the pair of coils must become minimum. And for this to become minimum, what should the ratio of the two currents be? What should the ratio of I1 to I2 be? That is the question. So let's assume that the ratio of the two currents is some K. Okay, already K is what? Coupling coefficient. Let's say I1 by I2 is what? Some R. Okay, I1 by I2 is what? Some R. So you just have to find the value of R that will make this, total energy minimum. Okay. So once you assume I1 by I2 to be R, I1 can be written as what? R times I2. Now in place of I1, we can write R times I2. Then you're going to get half L1 R square I2 squared plus this term I'll write it as it is, half L2 I2 square. And the last term, in place of I1, if I write R times I2, then it will become MR I2 square. Now, as you can see, I2 square is common to all the three terms. So if I just bring out that I2 square thing, then I'm left with I2 square into half L1 R square plus half L2 plus, okay, here plus m r. That's all. Now, for the total energy to become minimum, this factor should become minimum. And this factor, this term, is it not a function of r? So you just have to differentiate this factor with respect to r and then equate it to 0. Let us differentiate this with respect to r and see what we are going to get. When you differentiate only this factor with respect to r, what do you get? L1 r. Second term does not have r, derivative would be 0. And third term mr, derivative with respect to r, is simply going to be m. Equate this to 0. So what is the value of r? Minus L1 by m. Minus L1 by m. That is the value of r. Okay, in fact, I mean, if you consider the other case, okay, where the two fluxes will be in opposite direction, then this term would become negative. And then if you repeat the same procedure, then you will get r to be what? Plus L1 by m. So strictly speaking, because whether it is additive flux or opposing flux is not given, r can be what? Plus or minus L1 by m. This has to be the answer. But if you just go by the given options, all options are negative. Okay, so let's forget about the plus case. Let's only focus on the minus case. And we also worked out for the minus case only. And the answer is what? Minus L1 by m, which is option B. Okay. So I guess I solved 3 questions from networks. So in the meanwhile, I'll try to collect some other questions from these subjects and hand it over to Hemant sir. Hemant sir will discuss digital and electromagnetics questions. Okay.
Okay. So first I'll take the question from digital electronics, and before we start with the questions on digital electronics, I've seen the polls. We have got almost like 1,000 polls, and out of which nearly some 56% found the paper to be moderate and 17% to be easy, and around 27%, 1/4 of the people found the paper a bit hard. Okay, but yeah, it's heartening to see that most people found the paper to be moderate. So overall level, even I've spoken with a few students who came to the institute also just now. So even they said that paper was more or less in moderate nature. Okay, so first we'll look at the question from digital electronics. Okay, so it was a question basically on K-map minimization, and that too the function was given straightforward. There was a function which is function of uv, in fact w and x. Okay, and the function was given as product of max terms format. So you have u bar plus v bar plus w bar plus x bar, one max term. Second one is u bar plus v bar plus w bar plus x, and the next one is u bar plus v plus. If you look at the max terms were given in such a way that there is one variable difference between pairs taken, two pairs taken together, right? So in the first and second, if you clearly notice, there is only x which is varying. The remaining part is exactly the same. So means the variable x will be eliminated in the first two terms combined when you combine both of them, because u bar, v bar, w bar, here also u bar, v bar, w bar. And then again, third and fourth terms also, if you notice, third and fourth max terms too have only one single variable difference, which is nothing but x. Okay. Again, the first three variables remain same, u bar plus v plus w bar. So why we are pointing out this part is nothing but we don't have to draw K-map. If you want to draw K-map, that's okay. But rather, if you want drawing K-map, in fact, that's only for cross verification purpose. Okay. Yeah, so when you minimize the first and second terms together, you will get u bar plus v bar plus w bar. And 3 and 4, when you minimize both of them, then you will get u bar plus v plus w bar. Okay. Again, in these two cases, we have v, the only variable which is changing. Okay. Whereas the remaining part u bar plus w bar remains same, means here the variable v is eliminated. And the final answer now becomes, okay, as per the minimization, this is u bar plus w bar. So the options were given in terms of logic gates. Okay, so the correct logic gate circuitry for this is nothing but NOT gate, and then OR gate. Okay, it was MCQ question. So because which the variables here are nothing but u and w, and finally the answer is u bar plus w bar. Okay, but like I've told, if you want to draw the K-map and solve the question, that's up to you. And here in terms of K-map, let's write them at least in terms of numbers. In terms of numbers, what is this guy? Wherever there is a bar in terms of max term, it corresponds to a 1. So because which this becomes 1, 1, 1 and 1, which is max term 15. This is max term 15, and this is 1, 1, 1 and 0. So which is max term 14. 1110 is nothing but 14, whereas this is 1, 0, 1, 1, which is 11. So this is max term 11. 1, 0, 1, 1 corresponds to 11. Okay, and then here we have 1, 0, 1, 0, which is max term 10. Okay, so finally we have the function now given as product of max terms. 4 max terms we have, which are 10, 11, 14, 15. Okay, so by using this max terms representation 2, we can construct the K-map, go for the minimization, get the answer. Okay, so let's construct the K-map here. But like I've told, in exam you have to be very cautious regarding the time. So the Boolean law method, this method will take obviously least amount of time because the data was given to you in a comfortable fashion. Okay. Yeah. So we have 10, 11. So this is cell number 8, 9. This is cell number 10. This is cell number 10. So max term corresponds to a 0 in the K-map. So 0 here. This is cell number 11. Another 0. We have 14, 15, 15 and 14. So these are the max terms we have. If you form the grouping, a grouping of all these 4 zeros, what do we get? Here in the grouping of zeros, wherever you see a 1 will be taken in the complement format. So u is 1, so u bar plus, in the last 2 columns, if you see w is nothing but 1, so w bar. Okay, u bar plus w bar is what we have, is what we have got in this approach also. Okay, if you want to go for the K-map approach, up to you. If you want to go with this direct minimization of the function by using Boolean laws, that is also another approach. Okay, yeah. This is in fact, I was surprised when I came to know that this was a 2-mark question. This question deserves to be a 1-mark question, not a 2-mark question. Okay. Next, coming to EMF, there are total 3 questions from EMF. So now we look at EMF questions. So the first question from EMF is, let me write the question here. The question we have is, we have 2 coaxial cables. Radius is nothing but A here, inner radius, outer radius is B, and in between the inner and outer conductors we have dielectric medium, and the dielectric constant is epsilon 1. Okay, and in the next case we have another coaxial cable, same inner and outer radius as compared to the previous case, but now this is divided into 2 parts. One half has the same dielectric material as compared to the previous case, epsilon 1, and the second one is K times epsilon 1. Okay, in such a way, if the capacitance here is nothing but C0, and here the capacitance is equal to 5 times C0, Okay, so then the question is, what is the value of k? What is the value of k? Okay, so this is basically what you are supposed to find out. Again, this question is a question, if you see from the recollection notes that I gave you, it's a direct question from the recollection notes. Okay, now what is the capacitance C naught? So capacitance C naught is a direct formula, 2 pi epsilon 1 times L divided by ln of B by A, right? Now what is the capacitance here? Here we have two capacitances, both of which are in parallel. Okay, so we have this capacitance, we can call it as C1, and another capacitance for the second half, C2. Both C1 and C2 are in parallel configuration. So in this case, what is the total capacitance? The total capacitance C equivalent is nothing but this is C1 plus C2, and this becomes equal to, see, for how much angle medium 1 is there and for how much angle medium 2 is there, 180 degrees out of the total 360 degrees, right? So 180 degrees divided by 360 degrees, I'm just going with the formula, times first one. First one is 2 pi epsilon 1 L divided by ln of B by A. Okay. The second medium is also present for 180 degrees. So because which 180 degrees divided by 360 degrees into 2 pi epsilon 2. What is the value of epsilon 2? It is nothing but k epsilon 1 times L divided by ln of B by A. L corresponds to the length of the cable. Okay. And you have been told that this becomes equal to 5 times C naught. So 5 times, what is the value of C naught? C naught is nothing but 2 pi epsilon 1 times L divided by ln of B by A, right? Now here, if you notice, this 180 by 360 becomes 1 by 2, 180 by 360 becomes 1 by 2, okay? And 2 pi epsilon 1 L ln of B by A, 2 pi epsilon 1 L ln of B by A, 2 pi epsilon L ln of B by A is gone. So ultimately all you have here is nothing but 5. So this is now 5 becomes equal to, so here 5 becomes equal to, this is entirely 1 by 2, 1 by 2 plus this is entirely k divided by 2. So k by 2. Okay. So if you take 2 common, LCM, send it to the other side, we have 5 into 2, 10, k plus 1 is nothing but 10, and from this k becomes equal to 9. Okay. So from this k becomes equal to 9. Again, this is a very simple question, only this expression looks lengthy but rather not a tough expression. Okay. Yeah, and again I was surprised to know that this is also 2 mark question. Okay. 2 mark NET question, I believe this is. Yeah, the next question is, the next question from EMF is, we have a spherical volume distribution, or spherical volume distribution of rho v is equal to minus 3 rho naught. Okay, minus 3 rho naught, and this is coulombs per meter cube, where rho naught is a positive number. It has been also given that rho naught is positive and it is a constant value. So rho naught is a constant value. Okay, so then you are supposed to plot, ultimately the goal is to plot E versus electric field intensity versus the R. Okay, and furthermore this spherical volume distribution is present for a radius of A. Okay, so the radius of the charge cloud is also given. So the radius of the charge cloud is equal to A. Okay, see, again this is a straightforward recollection notes question. If you look at the recollection notes, same exact question we have in the recollection notes also. So here we'll have 2 parts, inside as well as outside scenario. So here rho naught is constant, right? So since rho naught is constant, we can say that this is uniform charge distribution scenario. Uniform charge distribution scenario. So in case of uniform charge distribution scenario, for the inside case, okay, so for inside case, when I say inside case, we mean to say R, examiner use the notation of capital R less than the radius. Okay, so in this region, what happens is nothing but the value of electric field intensity. The formula for electric field intensity is given by, so this is rho v divided by 3 times epsilon naught. Okay, so this is the expression, and direction is always r cap direction, radially away direction. So all you have to do is substitute this value of rho v, rho v into r divided by 3 epsilon. So where r is nothing but the distance from the center, but in this case they use the notation of Kepler, so I'll be using the same notation. So rho v value is nothing but minus 3 rho naught, okay, is what I substituted, into r divided by 3 times epsilon naught. Okay, and if you do the cancellation of 3 as plus 3, so finally the answer is minus rho naught r divided by epsilon naught. Okay, so clearly you can see that electric field intensity is proportional to r. Electric field is proportional to, okay, r for the inside region, and for the outside region, when we say outside region, we mean to say r is greater than a. So in this case, electric field intensity is given by, this is rho v into a cube divided by 3 times r square. So this is the formula we have, and when you substitute the value of rho v here, rho v is minus 3 rho naught into a cube divided by 3 times r square. Okay, so this becomes equal to minus rho naught a cube divided by 3 times, by r square. So again, from this expression, if you notice, electric field intensity on the outside region is proportional to 1 by r square. And furthermore, for both inside as well as outside region, electric field intensity is negative value. Okay, so options for all graphs. So options were given as simply graphs. So if you plot both for inside as well as outside scenario, the plot looks something like this now. So this is r. Let's assume somewhere here we have a. So from 0 to a, the electric field intensity linearly increases in terms of magnitude, but rather it's a negative number. So because of which the plot will be looking something like this. Yeah, it is linearly varying from where to where? Until a. Until a, it linearly varies, but rather it's always a negative value. And how much is the peak value? The peak value in terms of magnitude. So if you look at the previous, this expression, no, all you have to do is nothing but substitute the value of r to be equal to a. If you do that substitution here or here, doesn't matter. Here also, if you substitute r equal to a, what do we get? The peak value becomes equal to rho naught a cube by a square. So rho naught a cube by a square is nothing but rho naught a. Okay, divided by, anyway, epsilon is there. Epsilon term anyway is common in the denominator part. Okay, yeah. And even if you substitute the value of r equal to a here, you get the same value. So basically at the boundary, that is at r equal to a, the value of electric field intensity both inside as well as outside remains same. Okay, and that value is nothing but, that value is minus rho naught a divided by epsilon naught. Okay, and on the outside, the magnitude varies in E proportional to 1 by r square fashion. So it changes something like this. Okay, so this is a graph for you, and here on the inside region, this is basically the inside region, and this is basically the outside region. For the inside region, okay, here electric field intensity magnitude at least is proportional to 1 by r, it's proportional to r, and on the outside region, magnitude of electric field intensity is proportional to 1 by r square. It decreases as r increases, the magnitude of electric field intensity basically decreases. Okay, so this is second question from EMF. There's the last question from EMF. The last question on EMF is a MSQ question. This is MSQ 2-mark question. Okay, so the field is something that we have used in our handout questions also. If you look at the handout questions also, we have used the same field. There is a field, vector field f of r, and that vector field is given as, this is r cap divided by r power n. Okay, and you have been told that divergence of this vector field is independent of R. So the examiner told you that a divergence of F bar, okay, is basically independent of R. Independent of R. Okay. So in that case, what is the value of, what are the possible values of n? Okay, so then the question is all about what are the possible values of n for which this happens, for which divergence of F bar is basically independent of n. Okay. So in the handout, we have given the same question, but rather we have asked you, if this field is solenoidal, then what is the value of n? That was the question. In fact, I have given the question as nothing but r power n into r cap is what I have given. And whenever this field is solenoidal, in that case, what is the value of n is what I have given. Whenever the field is solenoidal, then divergence becomes equal to 0. And when divergence is 0, again, obviously, the divergence is independent of r value there, right? So one part of the question, in fact, handed question is basically one part of the question, not the entire question. Independent of, independent of R. I'm sorry. It has to be independent of R. Right? So let us see the divergence. Divergence in case of spherical coordinate system is given by, so del dot F bar, this is equal to 1 by R square sine theta. Okay. I'm writing the curvilinear formula. First one, dou by dou R. We only have R cap terms. Dou by dou R of H2, H3, which is R square sine theta. Okay, into the r cap component. R cap component is here 1 by r power n. So this is 1 by r power n. I'm using my notation. My notation smaller is what I use. Okay, instead of capital R. And we don't have theta terms, we don't have phi terms, so other terms are gone. And in this calculation, as you can see here, sine theta as well as sine theta is gone. So the overall expression now becomes equal to, this is 1 by r square. This is r square r power n, r power 2 minus n. This is, so dou by dou R of R power 2 minus n. Okay. And when you differentiate this term, you get this as nothing but, this becomes equal to 1 by R square into 2 minus n. Okay. Into R power 2 minus n minus 1 becomes equal to 1 minus n. Okay. 1 minus n. Overall, if you take this R square also, if you take the ratio of R square also, we get this as nothing but 2 minus n into, this is r power, I think it is minus 1 minus n. So this is r power minus 1 minus n. Okay. So this is what you have. And examiner told you that this value has to be independent of r. So when will this be independent of r? Only whenever this n plus 1 term becomes equal to 0. Okay. So for this condition, as you can see here, so this term has to be equal to 0. Okay. So this term has to be equal to 0. Means minus n minus 1 should become 0. So it means that n should become equal to minus 1. Okay. So this is one possibility. One more possibility is nothing but whenever n becomes equal to 2, one more case, whenever n becomes equal to 2, this entire differentiation becomes equal to 0. Okay. So same thing, whenever you take divergence, again for the second time, divergence of F bar becomes equal to, formula is 1 by R square sine theta in curvilinear format, dou by dou R of R square sine theta into 1 by R square. Okay. Sorry, 1 by R power n. So this is the second case now. The second case. So in this case again, so this becomes equal to 0 whenever n becomes equal to 2 for you. Because whenever n is 2, so in this case 1 by r square and r square is gone. So dou by dou r of a constant value where there is no r becomes equal to 0. So then also what happens is nothing but we have divergence being independent of r. Okay. So now we have two answers. One is nothing but n is equal to 2 and one more is n is equal to minus 1. Okay. So these are the two answers for this particular question. This is MSQ. So there are two correct answers for this, minus 1 as well as plus 2. Okay. Yeah. So these are the questions from EMF as well as from digital. from digital, I would say fairly very easy question. And like I've told you, I'm surprised that when I saw that question as nothing but a 2-mark question. It was supposed to be a 1-mark question, but rather it was a 2-mark question. And even from EMF, the questions are straightforward from the recollection notes if you follow the recollection notes. Okay, so I would overall rate EMF as well as both digital to be on the easier side, not even moderate. I would say they are on the easier side only. Okay, yeah. So next, yeah, Giri sir will start with power system. He is very eager for a long time. Yeah.
So, good evening, all. So, I hope you given the paper well. So, paper. See, when I see, even I also given the paper in the examination hall. I thought that the paper is bit tougher side. But after coming out of the examination hall, when I see the questions, even of power system questions and all questions, they're just simple questions. I mean to say somewhat easy questions. But even if you are not given the paper, I mean, if you thought that the paper is tough and you are answered only 50% of the questions in the examination, don't be panic. Definitely you will end up with a good rank. So because the pressure you face in the examination hall is really different. Okay. After coming out of the examination hall, and if you see one by one question, every question looks somewhat simple. But when you are facing the real question in that pressure, no, so definitely everybody will feel that it's a tough question. So overall, if you see from power system questions, total 9 marks given from power system, 3 1-mark questions, 3 2-mark questions. Okay, 3 1-mark questions and 3 2-mark questions. Now, if you see the topic wise, let me write the questions given. Now, if you see load flow analysis is given 1-mark question, which is MCQ, and it's a very simple question. And again, many people confused to answer this question. Even some great lecturers also given wrong answer for this question. Okay, anyway, I'm going to discuss that question. Next, stability analysis, power system stability. There's a 2-mark question given. Again, it is also MCQ question. Okay. And then fault analysis. 1 question is given. There is a 1-mark question on jet bus. I told you in the classroom, jet bus approach for solving fault analysis. Even I told you that jet bus approach, okay, generally it is an untapped area. Even I used to solve 1 or 2 examples in the classroom, and even I given 1 homework question also in the classroom. Please try to solve this kind of question. Sometimes if the question is given from this area, nobody will answer. Only the people who have a better practice only can answer. But it's a very simple question is given. It's for 1 mark given. And then there's a question is given from, yeah, this is I say PS2 part. PS2 deals with power system analysis. From power system analysis, 4 marks given. Out of 9 marks, power system analysis, 4 marks given. Then coming to T&D, okay. Now T&D we have so many topics. Actually T&D lengthy area. I used to solve so many lengthy questions, so many questions in the classroom. But at the end of the day, very simple questions are given from T&D. Okay, 1 question is given from power factor correction. Power factor correction, 1 question is given. That is for 2 marks question. Okay, so 2 marks question, which is NAT question. This is also NAT question. No MSQ questions given from power system area. Then, yeah, there is a, it's a general question. I can say it is a question from, he has mentioned that there is a distribution feeder having R by X ratio 5. Then what is the condition for, what is the power factor for maximum voltage drop in the feeder? That is a question. But maybe by seeing that word feeder and distribution system, the people may feel that this is a question from distribution system. No, it's actually a question from short transmission line. That means performance of lines. Okay, it's a performance of line, and that too, performance of lines, that too on short transmission line, short line, the question is given. Short line performance, the question is given, and that is for 2 marks again. Yeah, I think it's for 1 mark question. It's a 1 mark, and yeah, again NAT question, 1 mark NAT question. Okay. Then yeah, so this is for our T&D. I say PS1. So from PS1, 3 marks given. So total 7 marks. And what about 2 more marks? Then PS3. If you see PS3, only we have few topics. I used to say in the classroom also, when I am teaching PS1 and PS2, at the end of the PS2, even I told you, when you are attending the PS3 means at least you please try to attend for economic load dispatch, because damn sure every year 1 question from economic load dispatch. I used to say this keeps on, but many people will not attend PS3 because they will think that the PS3 is very less important for GATE. Yes, that's true, but economic load dispatch is very important. Yes, there is a 1-2 mark question is given from economic load dispatch, direct question, but it is not a direct question. I can say it's a somewhat indirect question, bit tricky question, bit lengthy question, but you have to if you use aptitude skills, you can easily solve this question. Okay, this is economic load dispatch, 2 marks question. Again, this is an NAT question. Okay, now if you see protection, no question is given. The entire system protection, I used to teach 40 hours in the classroom, no question is given. But now also I always say protection is very, very important for interviews, and also important for engineering service exams, and also it is very important for the Transco, Discom exams and Genco exams. Okay, so don't take it light. Now after the GATE exam, now the GATE exam is completed. Many people from AP and Telangana region, because so many notifications expected, the people are trying to prepare for this Transco and Genco jobs. Don't neglect the protection, boss. GATE exam 0 marks given, but Genco, Transco exam, maximum questions you can expect from protection. Okay, so anyway, so economic load dispatch 2 marks given. This is what the overall GATE paper. I can say PS1 3 marks, PS2 4 marks, and PS3 2 marks. And load frequency control also no question is given. Last year 1 question is given from load frequency control, that is MSQ question, given for 2 marks. But this year I say no question is given from load frequency control. Now we'll see 1 by 1 question. Now I'll see first question here, that is based on load flow analysis. All great lecturers given wrong answer for this question. It's a very simple question, my dear. See, I used to discuss this every time in the classroom. When you want to run load flow analysis using any method you take it, it might be Gauss method or Gauss-Seidel method or NRLF method, any method you take it, whatever may be the buses you have, at least we need one slack bus. Without a slack bus, it is impossible to solve load flow program. Yes or not? Without a slack bus, it is impossible to solve load flow program. You may have a PV bus or not. Definitely we have a load buses. Load will be there. Apart from load, definitely one generator must be required to supply the load. Yes or not? Common sense, na? Load is there. Definitely you need a generator to supply the load. So if you have a generator bus, definitely one generator bus means what? Always it is treated as a slack bus. Okay. Now the question is framed like this. Okay. I will write the question here. Okay. So actually it's a bit lengthy question. I will read the question clearly. Okay. A domestic consumer installed with UPS. Domestic consumer installed with UPS. Installed with UPS. Simple. It is your house. Domestic consumer means what? Your house is an example of domestic consumer. Your house having UPS installed with UPS. UPS means what? Uninterrupted power supply. And it's clear mention. The domestic consumer lost the supply from the distribution company. Okay. So no supply from distribution system. If there is no supply from distribution system, then what? This UPS supplying what? Fans, TV, lights, etc. This is what the data given. Some lengthy data given, etc. Okay. Yeah. So fans, lights, and TVs and other loads. Okay. Now, while solving the NRLF, if NRLF method is solved for this system and the UPS is maintaining constant voltage, that is the data given. The UPS is maintaining constant voltage while solving NRLF. The UPS is treated as, that is the question. While solving NRLF, the UPS is treated as. What is having here? UPS means what? It is just like a generator, right? Equivalent circuit, generator, and supplying some load. It's a generator load bus. Yes or not? Clear? Generator is supplying some loads. Okay, you may say that in between generator and what? Loads, we have some lines. That means house wiring. This is what house wiring. Okay, you have a separate bus, generator bus and load bus. Okay, this is what? UPS. All these fans and TVs I am considering as what? Another bus. Then what is this UPS is treated as? Slack bus. Option A, slack bus. Option B, PV bus. Option C, PQ bus. Option D, PQV bus. This bus not at all exist. Okay. So many people will confuse here. They will see that it's a PV bus. Many people may say that it's a PV bus. Why? Because since he has given a confusing statement that UPS is maintaining constant voltage. A slack bus also maintains a constant voltage. Yes or not? Slack bus is a generator bus. Generator will always maintain the constant voltage at its terminal. Okay. PV bus maintain the constant voltage at its terminal. But we lose the underlying statement that what? Slack bus also maintain the constant voltage at its terminal. Now, why not? Why this answer is wrong? Because is clearly mentioned NRLF method. While solving NRLF method, if I want to solve NRLF method, you may have n number of load buses. You may have n number of PV buses, but you should have a slack bus must. Slack bus must be a generator bus who has to maintain the constant voltage, who is capable to supply both active and reactive power. Yes, this inverter UPS system will supply the active power as well as what? Reactive power. The best example is your house. Whenever you lose the supply from what? Distribution company, your fan is running, means that fan is drawing active power and reactive power. Yes, that inverter is supplying, my dear, both active and reactive power. Now tell me, it should be a what? Slack bus. Because without slack bus, it is not possible to solve what? NRLF method. Okay. PV bus is 0, that's possible, correct. Even I discussed one question, how to find the maximum size of Jacobian while solving NRLF method. Maximum size of Jacobian is possible if number of PV buses are minimum. Minimum means 0. All buses are PQ buses except one bus. That one bus is what? Slack bus. We should have a slack bus and it should be a generator bus. Means who is capable to supply both active and reactive power. Yes, UPS is capable to supply that. So that's why the answer is slack bus. Many people are saying it is a PV bus. It's blunder. Okay, clear? It's a slack bus. The UPS is now act as what? Slack bus, because it's clearly mentioned NRLF method. Okay, so that is a one question. It's given for 1 mark. Okay, it's a very simple question. Whoever attended my class also confused to answer this question. I met some students after the paper. They are saying that, sir, this is the PV bus. No, it's a slack bus. Okay. Anyway, that is a one question given. And there is one more question. We'll see that. So, as per the data I got, okay, actually a jet bus is given. I don't have a data regarding complete Z bus, but I have a data for Z12, that is 0.069. I don't have this data. This one I don't know. This one I don't know. And this is also given. Actually, Z11 given, Z12 given, Z13 given. Every information is given. But to solve this question, these two required. That's why I remember only these two values. So once the complete paper is out, okay, response sheet is out, then in that case, in that time, we'll see once again with complete data. But this is enough. This information don't know. Even if this is known, the same thing here. Okay, Z bus is given. It's mentioned that there is a three-phase fault. Three-phase fault with fault impedance. Fault impedance also given. I remember that J 0 point. Here I mentioned, okay, J you take here. Then J is not required here in that case. Don't confuse. J is not required here. Okay, chalo. Yeah, the fault impedance is given J 0.007. James Bond 007. No. J 0.007. Chalo. This is what the fault impedance given. Now, there is a three-phase fault at bus 2. There is a three-phase fault at bus 2. The pre-fault voltage of all the buses are given 1 per unit. Pre-fault voltage means what? Let me write like this: V1 of 0, V2 of 0. Since it is a 3-bus system, before the fault, all the bus voltages are 1 per unit. Similar kind of question is given in GATE exam, GATE 2006. Okay, similar kind of question is given. Okay, so that time we have a common data questions. And the common data is given, Z bus given, Y bus given, and he asked to find out post fault voltages and also the per unit fault feeds from the generators at bus 1 and bus 2. Something like question is given. Okay, anyway, so pre-fault voltages are given. The question is what? If there is a three-phase fault at bus 2, what is the post-fault voltage? What is the post-fault voltage of bus 1? So, what is the post-fault voltage of bus 1? We have a direct formula to calculate the post-fault voltage of bus 1 using compensation theorem. Okay, so the post-fault voltage of bus 1 is what? V1 of 0 minus Z12. Z12 from what? Z bus matrix into what? Fault current. So first of all, we should know the fault current. So what is the fault current formula? Since the fault is at what? Since the fault is at bus 2, the fault current for a fault at bus 2 is what? V2 of 0 by Z22 plus ZF. I hope you understand why I remember these two, because these two are enough to solve this question. ZF given, Z22 given. Now this is 1. Z22 is what? J 0.093 plus J 0.007. If you add this, we get in the denominator J 0.1. So the answer is what? Minus J10 per unit. All are in per unit. All are in per unit. Is also per unit given. Z bus also given in per unit. Don't confuse. Chalo, fault current you got now. Then what is the post fault voltage? Pre-fault voltage minus J 0.069 into minus J10. Minus into minus plus J into J minus. So 1 minus 10 into 0.069 or 10 in, that means 0.69. So this is 0.31. Okay. So this is again NAT question. The answer is what? 0.31. Okay. Clear? So this is another 1 mark question. So it's given from fault analysis, right? Now, there is a question given from, again, yeah, I'll write that question. There's a 2 mark question from TND, that is from power factor correction. It's a numerical answer type question. NAT 2 marks question. So I have an exact data for this question. Using a shunt capacitor, using a shunt capacitor, the power factor of a the power factor of a 3-phase 4 kV induction motor, and is clearly mentioned in the bracket. The motor is drawing 390 kVA at a 0.77 pf lag, bracket close. Using a shunt capacitor, the power factor of a 3-phase 4 kV induction motor is 0.85 lag. Okay. The line current drawn by the capacitor bank is, it's not a straightforward question. It is somewhat different question. The line current drawn by shunt capacitor is this is the question. Now, if you notice here, we have an induction motor, let's say, and you have a shunt capacitor. Now the induction motor is operating at 0.77 lag, but overall power factor is what? 0.85 lag. You can think like this. This is the old power factor, means before installing the capacitor bank, the power factor is 0.77. Before installing the capacitor bank means what? Cos phi 1. Okay, 0.77. After installing the capacitor banks, the power factor is what? Cos phi 2. What is that? 0.85. If that is the case, we have a simple formula, direct formula. What is the rating of capacitor bank required to achieve the power factor, overall power factor to 0.85? Yes, by installing the capacitor bank, power factor will be improved. What is QC? There is a formula for QC. The power drawn by the load. This load is drawing some power. Induction motor, I am assuming load. It draws some PL and QL. QL is not required. PL is enough. PL into tan phi 1 minus tan phi 2. This is the formula. Okay. Once I know the QC, the formula for QC is what? Since this capacitor is drawing some current, voltage, line voltage VL, that is what? 4 kV. So we can use this formula, root 3 VL IL. What is the power factor of this capacitor? Unity. Sorry, the power factor is 0. That means what? Root 3 VL IL sin some phi. This sin phi is 1. I am talking only for this capacitor. The capacitor power factor is what? 0. Capacitor will not draw any active power. But capacitor cos phi 0. What about sin phi? Unity. Capacitor will not draw any active power. So using this, I can get the line current. Line current equal to what? QC by root 3 into VL. Okay. Let's calculate the QC here. What is the formula for QC? For that, we need first PL. Now. What is PL? I will write here, just see. The PL equal to what? SL apparent power into what? The power factor cos phi 1. Okay. Because this power factor 0.77 we know. What is this? 390. 390 into what? 0.77. Okay. Clear. Now phi 1 and phi 2 you need to calculate. So what is phi 1? Cos inverse of 0.77. What is phi 2? Cos inverse of 0.85. So directly I am writing here. So PL I am directly substituting. 390 into 0.77 tan of cos inverse 0.77 minus tan of cos inverse 0.85. So if I solve this, I got approximately 62.72 kVAR. So I got QC is what? 62.72 kVAR. All right. So now you substitute IL. IL equal to what? 62.72. This is K. In the numerator also, root 3. Line voltage is what? kV. So KK get cancelled. Then you will get the answer is in what? Amperes. Okay. Clear. So now tell me, if I solve this, we get approximately 9.054. 9.054 amperes. 9.054 amperes. Okay. So this is a formula based question where we need to calculate QC. Till here we solved in the classroom, but we didn't solve a question on how much current the capacitor is drawing. But you know, once you know the power, once you know the voltage, then you can use the common sense, basic fundamental formulas to calculate the current. But careful, only I am talking about capacitor. Capacitor current is what now? Let's say that is what IL. Okay, IC you assume better. You will not have a confusion now. The capacitor current is what now? IC. Okay, root 3 magnitude of VL, magnitude of IC. The capacitor always operated unity power factor. Power factor unity means what? Sorry, capacitor power factor is always 0. I am very sorry. So sin phi is what? Unity. Okay, if I talk only about capacitor does not consume any active power. P 0. That's why its power factor is 0. And in that case, sin phi is 1 for capacitor. So this formula, well-known formula. Q equal to root 3 VLIL sin phi. P equal to root 3 VLIL cos phi. Is that right? Okay. Chalo. Using that, we got the answer is what? 9.054, amperes. Okay. Yeah, this is also NAT question given for what? 2 marks. Right. There's one more question. So this question, again NAT question given for 2 marks from economic load dispatch. This is the economic load dispatch question. Carefully. So as per the data I remember, okay. So in a 2-plant system, okay, in a 2-plant, I'm not writing the entire data here, please. In a 2-plant system supplying load, for example, okay. So the question given like this: for an incremental cost of, if incremental cost is 10,000 rupees per megawatt hour, if incremental cost is 10,000 rupees per megawatt hour, then the economic dispatch is clearly mentioned. For an incremental cost of 10,000 rupees per megawatt hour, the economic dispatch, that is what? P1 50 megawatt and P2 80 megawatt. But before that, in the data it's mentioned that the rated capacity of machine 1 is 100 megawatt as per I remember, and the rated capacity of machine 2 is what? I think 150 megawatt. Okay, chalo. Rated capacity. Ratings also given. Okay. So incremental cost is given. If a incremental cost of 10,000 rupees per megawatt hour, P1, P2 value is given, and one more data given. If incremental cost is 10,600 rupees per megawatt hour, 600 rupees per megawatt hour, again the economic dispatch is, for an incremental cost of 10,000 rupees per megawatt hour, the economic dispatch given. Again, for an incremental cost of 10,600 rupees per megawatt hour, and the economic dispatch is given. The economic dispatch is such that, which is 80 megawatt and 92 megawatt. Okay, clear? Now, what is the question is, if it's a bit lengthy question, if incremental cost is 11,800 rupees per megawatt hour, if this, then the demand equal to what without overloading of any unit. Clearly mentioned, without overloading of any unit. Approximately this is the question. So for an incremental cost of 10,000 rupees per megawatt hour, what is the P1 and P2? Next, for an incremental cost of 10,600 rupees per megawatt hour, what is P1 and P2? And if incremental cost is 11,800 rupees per megawatt hour, what is the demand on the system such that no unit is overloaded? Means what? So for example, if it is a unit 1, it should not supply more than 100. That's what the meaning of overloading, right? And without overloading, right? Yeah. Unit 2 should not supply more than 150 megawatt hours. Okay. So if I want to solve now, I need to know here again P1 and P2. For this, what is P1 and P2? I need to calculate. But how to calculate that? We need to calculate here the incremental cost curves for both unit 1 and unit 2. Okay. See, what is the incremental cost curve for unit 1? Shall I write like this? For unit 1, IC1 equal to what? A1 P1 plus B1, right? What about IC2? A2 P2 plus what? B2. And we know that as per economic load dispatch, IC1 equal to IC2. As per economic load dispatch, IC1 equal to IC2. Right or not? So from the first case, I can write like this. What? 10,000 equal to what? 10,000 equal to A1 P1 plus B1. This is one equation. And another equation is what? A2 P2. I'm going to substitute now. A2 P2 plus what? B2. Tell me, what is this P1? P1 given 50. So P2 given what? 80. Generally what happens? A1, B1, A2, B2 values are given. We need to calculate what? P1 and P2. But this is a reverse question. Okay. So now, if it is 10,600 rupees per megawatt hour from the second information, I can model again two equations. What? A1, P1. What is P1? Plus B1. A2, P2 plus B2. Now here P1 is what? In this case 80 and this is what? 92. Yeah. So now if you see from these two, okay, if I solve, like for example, this is equation 1, 2, 3, 4. So from, if I do 3 minus 1, check it, 3 minus 1. 3 minus 1 means what? Check it here, 3 minus 1. Left hand side 600. Right hand side 80 P1 minus 50 P1 means what? 30 P1. I'm sorry, 30 A1. And B1 minus B1 cancel. So from this A1 equal to 20. A1 equal to 20. If A1 20, what is B1? So you substitute here. 20 into 50,000, B1 will be 9,000, right? Directly I'm writing. P1 50 now. A1 I got what? 20 now. 20 into 50. How much? 20 into 50. Let's see. 1,000. Okay. Clear? And 10,000 minus 1,000. 9,000. So B1 is 9,000. Right. Then if I do 4 minus 2. 4 minus 2. On the left hand side, again 600. But on the right hand side, let's see. Here 92 P2, sorry, 92 A2, and here what? 80 A2. That means 12 A2. So from this A2 you get what? 50. If A2 50, tell me, again you substitute here. 50 into 80, 4,000. 10,000 minus 4,000, which is what? 6,000. V1 is 6,000. So finally, what I got? The incremental cost curve of unit 1 is 20 A1 plus 9,000. The incremental cost curve for unit 2 is 50 A2 plus 6,000 rupees per megawatt hour. Now tell me, now present case, if the incremental cost is 11,800, here also 11,800, then you calculate, let's see, I'm sorry, this is P1, P2, okay, because A1, A2 I got, no? This is P1, this is P2, correct or not? A1, P1 plus B1, A1 is 20, A1, P1 plus B1, A2, P2, A2 is 50, B2 is what? 6,000, again this is B2, right? Chalo. Now, then calculate P1 and P2. If I solve this, 11,800 minus 9,000, from here I got P1 is what? Directly I am writing, don't confuse. 11,800 minus 9,000, that is 2,800. 2,800 by 20, this is 140 megawatt, which is not possible because P1 is exceeded the upper limit rated capacity. If I want to supply like this now, it will be what? Overloaded. Is clearly mentioned without overloading. Whenever any unit is whenever any unit is supplying more than its rated capacity, we limit the power output to what? Its rated capacity. Otherwise, if any unit is violated the maximum limit. Yes, it's a maximum limit violation because P1 you got 140, but what is the rated capacity? Maximum limit is 100. So that's why P1 we set it to 100. That's it, no doubt for this. P1 is 100 megawatt. Here the many people will confuse. Okay, P1 is 100. Now if we solve this, if I solve this, I got P2 is 116 megawatt. Check it here. How to solve this? Again, 11,800 minus 6,000, 5,800. 5,800 by 50. That means 580 by 5. That is 116 megawatt. Now tell me, what is the demand on the system without overloading of any unit? P1 plus P2. That is 100 plus 116. The answer is, 216 megawatt exactly. 216 megawatt. That is the exact answer for this question. Clear? Understand? This is the last question in stability. Okay. So that is also for 2 marks question. Okay. 2 marks MCQ question. This is quickly I will go through this question. So again, this is a normal question. Again, many people not answer this question because it's a equal area criteria question and the graphs are given, because in the question it's clearly mentioned you need to identify acceleration, correct acceleration area and deceleration area, and bit tricky question this was. Okay, let's see, the question follows like this. There is a generator feeding the supply to the grid through a double circuit transmission line. Grid means it's an infinite bus. Okay, there is a circuit breaker 1, circuit breaker 2, CB1 and CB2. It's clearly mentioned that the fault is very close to the bus bar. There is a fault happened. This is what triple LG fault, clearly mentioned. And also mentioned that it is a transient fault. Transient fault. And also mentioned that what? The fault is cleared initially. And later, due to the auto reclosing action, the line is what? Coming into picture. Means what? Initially fault is cleared by opening of the breakers. Okay. First of all, let me write first. Before the fault, if you draw the power angle curve. See, this is the power angle curve now before the fault. The generator is supplying some power to the grid now. Yes or not? Now tell me, this is what? Some delta naught. Fine. The moment there is a fault, 3-phase fault, very close to the bus bar, during fault electrical power becomes 0. Yes or not? Electrical power 0 now. Slowly moving. Then little later the fault is cleared. Fault is cleared very quickly as per the the options, 4 options given. Okay. Once the fault is cleared, it will go to what? Post fault curve. What is the post fault curve? Immediately after the fault is clear, faulty line is disconnected. Faulty line disconnected means what? The maximum power transfer will decrease. So this is what? Post fault curve. Okay, this is what post fault curve. But later what is mentioned? Since it is a transient fault, initially line is disconnected. Little later again the line is connected back. Once the line is connected back, the system become what? Pre-fault system. Now, what is the acceleration area and deceleration area? So once the fault is cleared, what happened? Okay, the electrical power will become 0. Sorry, during fault electrical power becomes 0. Continuously machine is accelerated. At this point the fault is cleared, but still you have deceleration area. Yes or not? So it will continue like this, but after this again what? The line 1 back into service. The faulty line which is initially disconnected means the operating point is on this. Now again the line is what? Coming into picture. The operating point jump here. Then maybe slightly forward swing. Then this is what? Delta max given. Delta max. After this delta max what happened? Finally the system is settled here. After few oscillations, after few forward and backward swing, it will settle here. Now tell me, what is the deceleration area? What is the acceleration area? Now this is what acceleration area. Mechanical power minus electrical power. Now tell me, what is what is deceleration area? Deceleration area means what? Yes, yeah. Just hold on. Yeah, the deceleration area is what? This one. Electrical power minus the mechanical power. Initially, this is what electrical power. Later, what? This is what electrical power till here. So this is what, you know, deceleration area. So this is the correct answer. Actually, 4 options given. With common sense also you can answer. Okay, but he has not mentioned the mechanical power line. This is the initial mechanical power. That is also final mechanical power. Okay, but this line is not given. But from the curves, if you notice, okay, there is a straight line you can draw. Okay, so that is what the mechanical power line. So this is this kind of picture. Yes, it is given out of the 4 options, but that is the correct options. Out of all power system questions, I felt little tricky is this question. The remaining all questions are what? Simple. Okay, and straightforward, and all questions are from our notebook only. Okay, clear? So that's about power system. These are the 9 marks given from power system area. Okay, so all the best. Now, so Rakesh sir will continue the session. Thank you. Half an hour. Half an hour.
No problem. Okay. Yes, students, just a second. Let me add on to some questions. Hello, hello, hello. Okay. Yes, students. Yeah, so, I have questions from math, signals, controls, and aptitude more. Some maths and questions of signals were discussed earlier, but I think students were looking for some aptitude answers. So let's discuss, a few aptitude questions and then moving towards control and the other area. Okay. So yeah, you can also share your opinion what you have given the answer for this. Spheres of unit diameter are centered at LMN, where LMN take every possible integral value. Okay, the center, okay, x comma y comma z, whatever you call, but it will be only integral value. The distance between 2 spheres is computed from center of one sphere to the center of other sphere. For a given sphere, x is the distance to the nearest sphere and y the distance to the next nearest sphere. What is the value of y by x? See dear, very basic, very logical question. Okay, very logical question. You just rule out 1 by root 2. Okay, because, okay, the x is the distance of the nearest to the next nearest sphere. Okay, oh sorry, you just have to, be very logical here. Why I was talking about 1 by root 2, you will understand. Okay, x is the distance to the nearest, okay, and to the next nearest sphere. Now, if you just be logical, I'll tell you the clear answer also, but if you just be logical, okay, I'm telling you 1 by root 2 will be ruled out because y is the distance to the next nearest sphere. Okay, so y by x has to be greater than 1. Na? Okay, y is the distance to the next one. So that is why I'm telling you to rule out B1. Now, what can be the 2 scenario? Okay, considering in the same plane, okay, let's say this center I take 0, 0, 0. Okay, because the center can only take integral value, what is the next possible center you can take? 1, 0, 0. Okay, next can be 1 and the unit diameters. They have unit diameters. Okay, so if this is 1, sorry, they have unit diameters. So then this can be the center 1, 0, 0. Okay, this becomes the distance of 1 unit, which is also equal to diameter. Anyways, there is some distance 1 unit here. Okay, the nearest one, because the center can only take integral value. So 1 is the simple in the horizontal line or vertical line. Next possibility you can take within the same plane, but take along a diagonal line. Okay, diagonal line means let's assume that this is 0, 0, 0, and assuming same plane means xy plane. So next center that you can assume is 1, 1, 0. Next center that you can assume is 1, 0, 0. Okay, so how much is this distance? Okay, y will be root over 2. But if I say this distance, x is equal to 1. So what is y by x is equal to root 2. Okay, is equal to root 2. And the other options are greater than that. Okay, the answer is only root 2. Okay, it will not be 2 root 2, it will not be 2. Okay, so answer is only simply root 2. Correct, dear? Let me know what have you marked this. Answer is root 2 here. Okay. Chalo, anyways, next question, dear. Okay, so what is the next question I have for you? Okay, so in the triangle PQR, okay, that is this triangle PQR, the length of PT and TR are in the ratio of 3:2. ST is parallel to QR. ST is parallel to QR. Two semicircles are drawn with PS and PQ as diameters as shown in the figure. This is a hand-drawn figure we got from the student. Which of the following statement is true about the shaded area? Okay, PQR. See, what is the first thing they have mentioned? That this length PT, what is that? The length PT and TR are in the ratio 3:2. That means I can take this as 3K and this is some 2K. Okay, but now you can see that ST is parallel to this. Okay, because these two are parallel. Okay, because these two are parallel, so these are corresponding angles equal. These are corresponding angle equal, and anyways, this angle is also equal. All the three angles are equal. All the three angles of the corresponding triangle are equal, and that also will then give you the relation. What are the triangles? One triangle you can take PQR, okay, PQR, and another one PST. Okay, so that means whatever is this ratio, if you compare side by side, PQ upon PS, okay, this PQ divided by PS, the bigger one, okay, or if I write in terms of smaller one, suppose PS divided by PQ, okay, should be equal to how much? Okay, PS divided by PQ should be PT is divided by PR. Okay, now what is the PT and what is the PR? PT is 3K, PR is 5K. So this is 3 by 5 ratio. That means PS and PS upon QS, this is also 3 by 5. 3 by 5. That means, dear, automatically this also becomes 3K and this also becomes 2K. Now the problem is done. Okay, because what they're asking, what is the following is true about, I'll show you the options about the shaded area. Okay, if you talk about the shaded area, see, first talk about the area with the semicircle, okay, with the diameter as PS, semicircle with the diameter PS. Okay, so what is going to be the area? Okay, first of all, don't write down the exact area. What I know is area proportional to, let's take diameter, na? Let's take the diameter. This will whole become diameter. Area proportional to radius square or diameter square. Okay, we can take that. No issues. Okay, so if you talk about the semicircle with the diameter as PS, okay, the area, okay, let's say that is area number 1, that will be, that area number 1, what has happened? That will be proportional to diameter square. Okay, so and the semicircle with the PQ, okay, with the PQ, okay, will be proportional to the 25. Okay, so because this is proportional, so let's say this is some 9K, diameter square 3. Okay, so this is some 9 times, okay, 9 into something, and the area A2, okay, the area A2 with the PQ as the diameter, this total diameter is 5K. Okay, so 5 square 25, 25 into some constant factor. This will be same constant factor. This will be same constant factor. So what is the shaded area? What one is the shaded area? Okay, the difference of this area, the larger semicircle with the PQ as diameter minus the area of the semicircle with the PS as diameter. Okay, so this is going to be how much? 25 minus 9. That will become 16 times this constant value. Whatever the constant, pi r square by 2 is the area of semicircle. I'm not writing then constant. Now, the statement is, okay, let me show you the statement. Which of the following statement is true about the shaded area? Okay, the shaded area is 16 by 9 times the area of the semicircle with diameter PQ. So we have to compare the shaded area, and it is sometimes of what diameter? So see, this is the shaded area, which is 16. Okay, and I think option number A itself is true. It is 16 by 9 times the area of the semicircle with the diameter as PS, correct? Okay, we can write down this one, 16 upon 9 into 9. See, this value, it is 16 by 9 of the semicircle with the diameter as PS. With the diameter PS, option number A. Option number A. So basic geometry question, I would say. Basic geometry question. Let me know if you have solved it and what is the answer you have got. Let's go to the next one. Okay, what is the next question I have here? A basic coding question. So in the given figure, EF and HJ are coded as 30 and 80 respectively. Okay, EF 30, HJ 80. Okay, which among the following given options is the most appropriate for the entries marked 1 and 2? Okay, now see dear, very basic coding, EF is 30, okay, where 30 is 5 into 6. Why 5 into 6? Because the position of letter E 5 and position of letter F is 6. Okay, then HJ is coded as 80. HJ is coded as 80, which can be split as 8 into 10. Why? The position of the letter letter H is 8 and the J is 10th letter. Okay, so 8 into 10. Now, if this is true, 1 is opposite 35, and also see the opposite. Okay, this is 80, so HJ also they mentioned 80. This is already 30 and they mentioned EF is 30. So similarly, 1 should correspond to, this 1 should correspond to 35, and 35 you can factorize as 5 into 7. Okay, 35 you can factorize as 5 into 7. The fifth letter will be E and FG, EG. Okay, that is EG. Only one option matches option number C, but still you can find the second also. Okay, then second corresponds to FG. Second opposite corresponds to FG, and F is how much? EF 6 and G is 7, 6, 7, 42. Okay, so this also matches anyways. Okay, so answer is option number C. Okay, answer is option number C. Okay, if this data is correct, then it is a simple question for 2 mark. It's a simple question for 2 mark. The geometry one, okay, expected for 2 marks, but the coding one is very simple. This sphere one also question for 2 marks. Okay, this is also decent. Okay, this is also okay, expected 2 marks. Some basic thought you have to give it. Take one. If you took the series in the same plane, you will get the easy answer. You get the easy understanding. This is okay. Right. Oh, this is mathematics already done, dear. Okay, this question has repeated. This is maths. This is not aptitude. This is inside the engineering maths. Okay, let's move it. I've done it in the beginning. I've completed this question in the beginning. Okay, so the next one, yeah, very basic question again, statistics, and again for 2 marks. So 2 marks questions of aptitude, except that geometry one or that coding one is easy to balance out, and this one is also very easy, basic statistics question. Okay, there are 2 entries given for the P and Q. Okay, and what they are asking is median score and average of Q are same, median score of P is same as Q, average of P is less than Q. So anyhow, median is required for both P and Q. Okay. Because in option number A, I need a median of P, and option number B, I need a median of P. Okay. So which of the following statement is incorrect? But for median, always we have to arrange the data in a sorted order. Okay. Whether increasing or decreasing. Okay. It has to follow the order. So this one is 22. Then next one directly I find, I think 45. Next, no, 39 is there. Okay. 39, 45, 50. Okay. And then the number greater than 50, 60. 78, 89, 1, 2, 3, 4, 5, 6, 7. Yeah, these are the 7 entries given. For Q, in the increasing order, it starts with 35, then I see 45, then I see 50, then I have a 56, then I have 60, then I have 65, and then I have 81. Okay, so 3 this side, 3 this side. So what is the median? The median of Q is 56, and 1, 2, 3 here. The median of P is 50, the median of Q is 56, and whether the median of P is same as Q, option number B is false. This is false, and because it is MCQ, okay, I think you should not waste time on any other calculation. That is the average and all. Of course, you have the calculator in hand and you can calculate the average, but that is not required. Option number B is the false, and we need to identify the false statement only, incorrect only. Okay, so directly by median, okay, I'm able to say B is definitely not correct. B is definitely not correct. Okay. Yes, Loku, correct answer B for this one, correct answer C for the previous one. Okay. So, what is the next one? Do we have any other question here? Yes. There are 2 more questions, 2 1-marker question, very simple. Okay, but yeah, before that, let me keep updated that yes, guys, the online live course. Okay, the online live course, fresh online live course for gate 26 as well as gate 27. Okay, that starts on 8th of February. This online live course starts 8th of February, and the fee for 1 year 19,999, and for 2 year it is 29,999. And yes, if you want to come and directly study at our offline center under the direct supervision of the faculties. Okay, faculties at both the places will get same, whether offline or online course. Okay, that is same, but yes, if you want to study, among the competition with students, real classroom atmosphere, then you can take the offline. The first regular offline batch for gate 26 starts 24th of February. Okay, 24th of February. Okay, now dear, next question for you. Find the value of 3 power 81 whole power 1 by 3. 3 power 81 is very basic simplification question. Yeah, dear, nothing is there. Very basic simplification question. 3 power 81 power 1 by 3. So this power multiplied divided by 27. Because power is 1 by 3 to 27, you can write 3 cube. Okay, so 3 cube into 4 and then into power 1 by 3. Okay, so this is 3 power 27 divided by 3 power 4. What else you can expect? This is very easy. 3 power 23. Option number C. Okay, option number C. Option number C. Right. Next one. Okay, a very, again, the basic graph, a straight line graph, okay, not even any, parabolic or sometimes logarithm graph. Then aptitude, sometimes they have discussed questions on logarithm or exponential graph, but this is a straight line. Okay, what is the, find the value of P and Q, the relation between X and Y, which is shown to be a straight line, is given to you, X plus Py plus Q. So, in any of the straight line formats, you can arrange or you can substitute the points, anything, you can do here. Okay, so what I am able to easily say that at x equal to 0, y is 4. X equal to 0, y equal to 4. Okay, so if x is 0, y equal to 4, so that means 4p plus q must be 0. 4p plus q must be 0. Okay, 4 times p here becomes minus 2 plus q equal to 0. Okay, this will not satisfy, this will not satisfy. 4 times p2 plus q. So if these options are correct, only option help you satisfy. Even you can find the equation of line, you can compare with the slope and other things also, but that is not required, because if you try to write down the slope, then you can directly get the slope will be how much? Minus 1 by p. Okay, minus 1 by p. Okay, if you actually go by slope, okay, or you can take the slope. Okay, slope is minus 1 by p, because if you write down y as a function of as a x, minus 1 by x into minus 1 by p into x. The slope is minus 1 by p, and how much is the slope? Okay, the slope is, the height is seen to be 4. Let's take this much of the portion, height 4, and this is base 2. Okay, this is base 2, increasing line. Okay, so minus 1 by p is equal to 2, and hence p equal to minus half. Then also only option number A. Then also only option number A. So even option wise, they have kept it very simple for you actually. Even option wise, they have kept it very, very simple for you. And option number A is the correct option. Option number A is the very correct answer, right? So now, dear, okay, other than this, there are some control systems questions with me. Okay, let me take the control systems question with me. Yes, where are the control system questions? Just a moment. Yeah, you don't have it typed, but yeah, okay, here it is. Let's move ahead to a control system question now. Let's move ahead towards a control system question. The question is, okay, it's a controller, PD controller, but very fundamental question. There is no role of the PD controller here. There is no role of the PD controller here. Okay, there is some controller gain named as CS. Then there is this plant. I'll write down the gain here only. 1000 root 2 upon s plus 10 whole square. Okay, and this is the output, unity negative feedback. Unity negative feedback. Okay, where the controller is given to you as 1 plus skd, which we know is a PD controller. Okay, what they have given is omega gc equal to 10 radian per second. Gain crossover frequency is given. The phase margin is given. Okay, the phase margin is how much? 45 degree. What is the value of the derivative constant, that is kd? What is the value of the derivative constant, that is kd? Okay, so this is again a simple one, dear. Now the point is they have given phase margin and omega gc are both required? No, actually, okay, by anyone you can solve. By anyone you can solve. If you solve from the omega gc, then also k approximately you'll get the correct answer. From phase margin, you'll get the more straightforward answer. Okay, can be solved by both. It can be solved by both means actually it can be solved by anyone. That is your choice. It can be solved by anyone. Okay, but yeah, the phase calculations will go easily. Okay, so the phase margin is 45, na? Okay, the phase margin is 180 degree plus angle. Let's say the overall gain, the overall angle. Okay, what is the angle required? Okay, the overall angle of the this system, the forward path gain, suppose that is G1. Okay, G1 is the cascade of this term. The angle of G1J omega GC at the gain crossover frequency, and this is given to you as 45 degree. So what is angle G1J omega GC? This must be minus 135. Okay, now what is the overall gain factor, overall angle factor for this? Okay, so what is the overall G1J omega? If I better write down in terms of the frequency domain directly, G1J omega, this becomes 1 plus skd, that is 1 plus j omega kd into 1000 root 2. That will not contribute to the angle part. That is why I am going by the angle calculation. Divide by j omega into j omega plus 10 whole square, where omega gc is given to you as 10. Omega gc is given to you as 10. Okay, so if omega GC is given to you as 10, then what is the angle? The numerator angle will be tan inverse of omega 10. So tan inverse 10 kd for denominator j omega. So denominator means minus, okay, 90 degree, pure imaginary term, and j omega plus 10 whole square. So 2 tan inverse of omega by 10. Omega is 10. So 10 by 10, 1, it will be 45 degree, and this should be equated to minus 135. Okay, so dear, our answer is obtained. Tan inverse 10 kd is minus 135 plus 90 other side, and this is 45. So this is also plus 90. So 90, 90, 180 minus 135, 45. Okay, so 10 into kd is how much? Tan 45 degree, that is equal to 1, and hence kd is 0.1. What I say, alone you can solve by omega gc also. At omega gc, magnitude equal to 1. We know that gain crossover frequency, the mod gj omega, the mod g1 j omega will be 1. There, that also you can get. Okay, but angle calculations are more straightforward. Okay, here. So the next question, this is one of the question from control system. Okay, I don't know the marking of it, but probably I say expect that it would be a 2-marker question. Okay, next question. Okay, a Nyquist plot question. A Nyquist plot question. What is given to you? Okay, what is given to you? Nyquist plot of stable function gs. Okay, stable function gs encircles minus 1 comma 0 once anti-clockwise. Okay, and some rough data I got for this question. The exact language is not there, but the theme of the question is complete. And the system function has the numerator which is s minus 3. Okay, has the numerator s minus 3. This is what is given. Okay, then okay, the closed loop system is what? Okay, the closed loop system, stable, unstable, marginally stable, okay, or fourth option can't be determined, something like that. Can't be determined. So see, here Nyquist contour is not given. Whether the Nyquist contour is clockwise or anti-clockwise, that is not mentioned here. The Nyquist contour being clockwise or anti-clockwise, that is not mentioned here, but no problem. Okay, now there is a stable function gs. Dear, if the transfer function gs is stable, that means p plus. What is p plus in our Nyquist formula? Poles of gs, poles of open loop transfer function in the RHP. Because that transfer function is stable, it will not have any RHP poles. P plus is 0. Okay, p plus is 0. Now, if I take clockwise Nyquist contour, if I take the clockwise Nyquist path, then n is equal to, what is the formula we use? P minus z, p plus minus z plus. Okay, number of encirclement minus 1 comma 0 once in anti-clockwise. Okay, p plus is 0 minus z plus. So z plus equal to minus 1, not possible. Z plus cannot be negative. The count being negative is not possible. Okay, so definitely you have to take the anti-clockwise Nyquist contour, anti-clockwise Nyquist path. Anti-clockwise Nyquist path, then we say that n is equal to z minus p, n is equal to 1, and it is equal to z plus minus 0. So z plus equal to 1, and the system is then unstable. Because z plus is what? Z plus is the zeros of the characteristic equation. When we are noting the encirclement of minus 1 comma 0, when we note down the encirclement of minus 1 comma 0, then z is the zeros of characteristic equation, roots of characteristic equation in RHP. And if you have one root of characteristic equation in RHP, system cannot be stable. Okay, great to know, Nagendra. State space model video. Yeah, coming. There is a very simple question of state space model. Very, very, very simple question of state space model was discussed. What is that simple question of state space model? Where is that gone? Okay. Okay, first I have a basic question. Stability question. You can call it as Routh-Hurwitz, or second order. We can solve it without the Routh-Hurwitz also. Okay, so what is given to you? Okay, unity feedback system. What is given to you? Unity feedback system. Okay, has the forward path gain. Now, what is that forward path given to me? Is k s minus 1 upon S plus 1, S plus 2 upon S plus 1, S plus 2. Okay, and question is there are 4 options. Option number A, system is always stable. System is always stable. Which system? Closed loop system is always stable for k greater than 1. There is some option number B. Okay, always unstable. A memory based question. Okay, and okay, if I solve it, what is my characteristic equation? My characteristic equation is 1 plus k s minus 1 upon the s plus 1 s plus 2 equal to 0. So this is going to give you actually a quadratic equation here. S square plus 3s plus 2 plus ks minus k equal to 0, or s square plus 3 plus ks plus 2 minus k. And here, yes, you can go for Routh-Hurwitz also, but for second order we can directly. Routh-Hurwitz for higher order, okay, you can go. But for second order, if all coefficients are of the same sign, system is stable. So we start with plus. So these two should be plus. If this is followed, then the system is stable for sure. For first and second order, if all coefficients are of same sign, system, you can confirm stable. You can confirm stable system. K plus 3 should be positive. That means k greater than minus 3. K greater than minus 3, and 2 minus k should be positive. That means k is less than 2. So what is the range for stability? The system is stable if k greater than minus 3 and less than 2. So minus 3 less than k less than 2, system is stable. That means option number B is correct. Always unstable. It is stable for up to 2. So it is 100% unstable for k greater than 2. Option number B. Okay, so as I told you, C and D not available, not required also. Not required also. Okay, so this is what is the correct answer. This is what is the very correct answer. Moving ahead to the next question then. The next question of control system, once again, a very, very fundamental question, state space. See dear, if you have listened to the simple points about state space, the system matrix I have told you, then this question is like, bonus for you. Okay, what is the question? Okay, there is a state space model given to you. Okay, state space model given to you, x dot t is equal to axt plus brt, and y of t is equal to cxt. A, B, C, D matrices are given to you. Okay, the A is 0, 1, minus 2, minus 3. The B matrix is given to you as 0 and 1, and the C matrix is given to you, sorry, B matrix is correct, 0, 1 transpose, and C matrix is given to you as 1, 0. And the question is, what is the sum of the magnitude of the poles? Okay, either sum of poles or sum of magnitude of pole. Okay, this is what is the question. Okay, either of this is the question. If you have the correct exact question, you can let me know. Okay, this is an oral question that I have got it. But yes, dear, okay, poles, if you talk about poles, okay, poles in state space model, if you have the state space model, poles are also the eigenvalues of the system matrix A. Okay, A matrix is given. Okay, A matrix is given. What is the characteristic equation? What is the characteristic equation? Lambda square minus trace, and trace is minus 3. Okay, trace is 0 minus 3 into lambda plus determinant 0 minus minus 2, that is plus 2 equal to 0. Okay, so lambda square plus 3 lambda plus 2 equal to 0, and lambda is minus 1 minus 2. So if this is the eigenvalues, their poles are also minus 1 and minus 2. Now see, let me tell you, if the question was only sum of the poles, if the question was only sum of the poles, yes, Nagendra, you are saying the answer 3, that means the question is sum of magnitude of poles. That is correct, because I'll tell you both the cases. If the exact question is find the sum of poles, then you don't need to find the characteristic equation also, because sum of poles means sum of eigenvalues, and sum of eigenvalue is equal to trace. That is directly trace. Okay, then the answer would be minus 3. Okay, if sum of poles, sum of magnitude of poles. Okay, so sum of magnitudes. So sum of the magnitude of the pole, answer I will write down here. Answer I'll write down here. Okay, it will be 1 plus 2, that is 3. Magnitude wise will the poles are 1 and 2. Okay. So if the sum of magnitudes, answer is 3. If the sum of poles, answer minus 3. But if the question is, I repeat, sum of poles, then you don't calculate the characteristic equation also. Then directly trace would be your answer. Okay, so yeah, controller question done, state space done, Nyquist plot done. Okay, the stability question done. Yes, I think I have one more. You let me know the correct data. This is some approximate data I have got a root locus question, and that is MSQ. That is a MSQ question also. Okay, so what is given to you? Again, GS is given to you. Okay, GS or GSHS, some S plus 2 upon S plus 4, S plus 7. The data may be slightly here and there. Okay, whether this is S plus 7 or S plus 6, that I have not got exactly. Okay. Which of the points below, lie on the real part of, will lie on the root locus, something like that, will lie on the root locus. All the options are real. Okay, all the options are real, and the options are something like that. Option number A, yeah, some option -3, some option is there as -1, some option is there as -6, and some option is there as -10. These are the 4 options. Okay, these are the 4 options, correct? You can let me know if there is any change in the data. This is what we have got. Whether it is S plus 4 or S, because option is -6, so maybe they have given S plus 7, or you can let me know the correction, not require. That's not going to change the concept of the question. Okay, so see, which points lie on the root locus? Number one is, okay, of course, some K may be given. Okay, this is what the question I've got. Okay, so, you know, magnitude criteria, phase criteria you can apply, but you know, it's a simple, all the points lie on the real axis. So we have the poles at, okay, we have the poles at origin and -2. Okay, origin and -2, sorry, zeros at origin and -2. No problem. We have zeros at origin and -2, and we have the poles at -4 and -7. -4 and -7. This is -2. This is -2 and 0. See, either you apply the odd number criteria. Okay, a point will exist on the real part, on the real axis, if the total number of forward poles and zeros is an odd number, or you can simply say that because 2 poles and 2 zeros, no asymptotes required, 2 root locus branches, okay, each starting from one of the pole, okay, will start in the opposite direction. They will intersect, so there will be a breakaway point somewhere here. Okay, then symmetrically they travel. Symmetry is important. Symmetrically they travel in the complex plane, and they come to a common point because of symmetry. That will be the break-in point. And after that they terminate towards the respective zeros. Okay, so which of the point will lie on the root locus? Okay, so -3 cannot lie. Okay, -1 definitely. -1 will lie. -6 will lie, but -10 will not lie. Okay. Yes, dear? Okay, S plus 5. Okay, no problem. Yeah, S plus 5. Okay, if it is S plus 5, then also it's not going to S plus 4, S plus 5, or S plus 5, S plus 7. Can you give me that correct data? Which term, Lakshman? Okay. S plus 4, S plus 7 if you say. Okay, then even -6 will not lie. Okay. So yeah, this is what was the theme of the question. Maybe I'm telling you, data, this is all memory based, some rough question I got it here. But yeah, data was something like this. This is what is the question. Okay. Chalo. So these are, I think, the control system questions I have got. Yes, and now I'll be calling Gautam sir for some more questions to be discussed. Yes, for some more question to be discussed. Yes, Aditya also says the term S plus 5, but which is the term S plus 5? I mean, which of the term to be replaced? Ramki says S plus 5, but tell me which term I should replace. I mean, which term is not there and which term is S plus 5? If you say that, then I will correct that question. Yeah, quickly. Better you say that quickly, dear. Just better tell me quickly which term I have to remove and which term I have to write S plus 5. Okay. Because MSQ, then only one option correct. That is also possible. In MSQ, we have seen only one option correct also is a possibility. Yes, dear, waiting for you quickly. S plus 4 to be removed. Okay, no problem. Then answers will not change. S plus 4 to be removed and to be written as S plus 5. No problem. I'll do that immediately. This is S plus 5. Okay, so if this becomes -5, -6 is still the valid point. -6 is still the valid point. Okay, -6 is still the valid point. Then options doesn't change. Options will be -1 and -6. Okay, done. then options also will not change. The same answers we can expect. Okay, dear. Okay, I think with some more questions of circuits and analog, Gautam sir is going to be there, and I will be coming back for some more questions of signals and maths. Okay.
All right, guys. I found 3 more questions, and these questions are from networks. I'll quickly try to solve these 3 questions. Okay. Uh, I think already I've discussed 2 questions from networks. The remaining 3 questions I'll discuss now. Okay. So I'll call this Q3. So some arrangement is given wherein you have a current source of value 1 amp, and across this you have a 1 kilo ohm resistor, and this terminal or this node is marked X, and this one is marked Y, and the current flowing from X to Y is denoted by IXY, and then the voltage between X and Y is denoted by capital V. Okay. They asked you to identify the correct plot between IXY and V. Okay, I mean this, we'll call it VXY. Okay. So what is the plot between IXY and VXY? I mean, there's nothing in this. The current in this branch is always 1 ampere. The current through this 1 kilo ohm resistor is going to be what? VXY by 1K. And then this IXY will be sum of, these 2 branch currents. So IXY is equal to what? 1 ampere plus VXY by 1K. This is very much like Y equal to MX plus C. Okay. So IXY versus VXY. Okay. So when the voltage across this branch is 0, the current through 1K would also be 0. Then the only current will be what? This 1 ampere current. Then IXY will be what? 1 ampere. So for VXY equal to 0, the current value is what? 1 ampere. And after that, if VXY becomes more and more positive, IXY also will increase. Okay. So VXY increases, IXY also will increase, and it will increase linearly. So among the options, there is the correct option. Okay. There is one more question that I found. This is an MCQ, and it is a 1-mark question. I think some statement is given. A nullator is defined as a circuit element where the voltage across the device and the current through the device are both 0. Okay. So there is an element called as a nullator, and for this nullator, no matter what, always the voltage and the current both are 0. Okay. So you can think of this as an element. This is the let's say this is the symbol for nullator. Let me erase this. Yeah. So for this element, the voltage is always 0. The current is also always 0. Okay. A series combination of a nullator and a resistor of value R will behave as. Okay. I'll write this statement. A series combination of a nullator and a resistance of value R will behave as. So 4 different options are given. Option A, nullator itself. Option B, is what? Open circuit. Option C is what? Short circuit. Option D is resistance of value R. I'll simply write R. So what is given? That in series with this nullator, we are connecting a resistance. Okay. So this is the nullator in series with which we have a resistor. So this series combination will behave like what? That is the question. So the series combination, you can think of it as a two-terminal element. Okay. So this is A, one terminal, this is another terminal B. Because see, for the nullator, the voltage drop is always 0 and the current is also always 0. Okay. So across this, what is the drop? 0. Through this, what is the current? Also 0. Now, because both are in series, even the current through R will also be 0. Current through R0, drop across R will also be 0. Now, what is the current flowing in this branch? 0. Yes. What is the voltage across this element, which is the combination of these two? 0 plus 0. Again, drop is 0. So, even for this combination, the voltage drop and the current both are always 0, which is the same for a nullator. So series combination of the resistor and the nullator will again behave as what? The nullator itself. Okay. I think we have one more question as well. Just a second. All right. So there is a 2-mark multiple choice question. A simple RC circuit is given. Okay, RC. And then the output is taken across capacitor. So it is what? Like an RC low pass filter. Okay. And then on this side, the input is applied, VI. And the input that is applied happens to be a square wave that switches between 1 and -1. Okay. This is the input that we have. So 1 volt minus 1 volt. This is t equal to 0. Is t by 2, t like that. Okay. And with respect to the RC circuit, it is given that RC is very large. The product RC, R and C are such that the product RC is what? Very large. Then V0 for a very high frequency square wave input. V0 is what? The output voltage or the voltage across the cap for a very high frequency square wave input will be, some options are given. Okay. Anyway, first we'll do the analysis, then we'll look at the options. So what does it mean to have a very large time constant? Okay. So a very large time constant, it means what? It takes a lot of time for this circuit to reach steady state. Whenever it tries to reach steady state, it is going to take a lot of time, which means circuit is what? Extremely slow. Circuit is very slow. Okay. And also its cutoff frequency is what? 1 by RC. So it is a low pass filter with a cutoff frequency of 1 by RC. And because it is given that RC is very large, the cutoff frequency will almost tend to 0. Okay, so it is like a low pass filter with a cutoff frequency which approaches 0. Okay, and then with regard to this input square wave, it is given that high frequency input square wave. So for this input, the frequency is very high. If the frequency is very high, it means the time period will be what? Really small. Okay, so T is what? Very small. If T is very small, T by 2 will also be very small. Okay. Now, if you look at this interval where the input is what? 1 volt. Okay. So this is 1 volt. So it is as if in this interval, a constant input of 1 volt or a DC value of 1 volt is driving this RC circuit. What happens generally is what? Cap will try to get charged to what? 1 volt. But then for that to happen, the cap will take some amount of time, like 4 to 5 time constants. And our circuit is what? Very slow. Yes. And the available time for the circuit to reach steady state is what? T by 2. And that is very small. Look at this. Our circuit is very slow. And the available time is what? Very little. So in that very little available time, given that the circuit is very slow, the circuit cannot reach steady state at all. Okay. So had it been fast enough to reach steady state, what would happen is, so if you try to plot V0 versus T, if the circuit is fast, I mean our circuit is not fast, but if at all it is fast, yes, within the given time, it will reach steady state. I mean, meaning voltage across the cap will reach 1 volt. Okay. Once it reaches 1 volt, it remains at 1 volt as long as the input remains at 1 volt. Okay. But this is not what will happen in our circuit. This will happen only when circuit is fast. But our circuit is what? Very slow. Yes. So instead of quickly rising, in an exponential fashion to 1, it would try to go to 1 from 0 volts, but it will do it very slowly. Okay. The charging in this interval will look like linear charging. Okay. So it will be like this. Okay. And then you will reach T by 2. So once you reach T by 2, the input will now become what? Minus 1. Yes. So now we are in this interval. Yes, where again the RC circuit is driven by a constant input of value minus 1. Okay. Now the cap will start discharging. Okay. So from this value, we'll try to discharge to what? Minus 1 volt. Again, that requires some time, and the circuit is what? Extremely slow. So it won't be able to do it. Okay. That is the thing. Okay. So it will do something of this nature. Okay. So whether it crosses 0 or not, you have to write the equation and verify. Okay. But at least this thing will happen. Okay. So you can expect something of this nature. This is the kind of output one should expect. Okay. So even otherwise, if you think in terms of frequency, okay, what is the average value of the input? It is 0. Okay, 0 to T by 2 it is 1. T by 2 to T it is what? Minus 1. Total area under the input waveform from 0 to T is what? 0. DC value of the input is what? 0. Okay. And low pass filter will definitely pass DC. But the DC value of the input is what? 0. So when you try to pass 0, whatever be the gain, the output will be 0. Okay. And then you also have the harmonics, okay, which are all at high frequency. But then our low pass filter has a very low cutoff frequency. All those harmonics, yes, including the fundamental, will fall at high frequencies which are far greater than the cutoff frequency of this low pass filter. Okay. So all of them will greatly get attenuated. So it will appear like this ripple. Yes. So this is very much a ripple. Yes. So all those high frequency components in this square wave will get severely attenuated. Okay. And if you try to draw the Bode plot of this circuit itself, mod V0 by Vi versus omega, it will be like this. Okay. This is what the cutoff frequency, you can say it is very, very small. Okay. And all your fundamental as well as the harmonics will fall in the stop band, which means they will get severely attenuated. Okay. This is the kind of output you should expect. Okay. Basically, it's a very slow circuit. So that's all with respect to networks. I'll again hand it over to Rakesh sir. He'll continue for the rest of the session.
Hello. Yeah. Yes, guys. So we discussed controls question. One more question of control system. Okay, a fundamental question only. MCQ 1 mark. Okay, so selected data points of the step response of a stable first order LTA system is given. What is the closest value of the time constant? Okay, it is directly a step response data given to you, and what you can observe here in the table is that when time becomes infinite, the output is 3. That means this is the steady state value of the output. Okay, so what is the time constant? Okay, for the first order system, what we will take it as that the final output is 3. The time at which the output is nearly 63.2%, 0.632 into 3. Okay, the 1 minus E inverse factor, which is roughly 0.632. So when you multiply this, this will be approximately some 1.8 something. Okay, let's do the rough calculation. So 1.8 something will come. Okay, so now you see the output at time equal to 1.6 is 1.65, and at 2.6 it is 2.18. And what I'm looking for, okay, output somewhere to touch around 1.8, 1.9. So that will be somewhere between these two values of time. And the only option available here is option number B. That is the time equal to 2. Okay, and that's why they've asked the closest value that can match. Okay guys, so very fundamental question. Now, okay, one mathematics question. Yes guys, this question in the beginning I told you that I need to confirm the options. Okay, now the correct options are there in front of you, and then okay, it is truly a 1 mark, very simple question. It is not on Kylie Hamilton, because p square here directly can be obtained by multiplying. Okay, so easily the options are arranged. Why? Because if you take p square just as a multiplication p into p, and 3 cross 3 multiplication, very simple only, because you see the most of the elements are 0 if you look into the matrix, and that is why it becomes just a bonus question for you. Most of the elements are 0. So let's do that quick multiplication. Okay, so what is the answer? The first row, 2, 4, and then minus 1, this is 3. Okay, then 2, this rest is 0 only. Then you go to third, it is 0. Okay, yeah, just keep checking the calculations. Okay, then this is minus 2, and then all zeros only. Okay, then minus 1, and then entirely 0. Third non-zero element. So here this is 0, here again 0, third column only 1 into 1. Okay, now you dear, what you observe is if you separate out I from here, okay, that means if I just try to add I here, okay, what is this p square? So if you add p square plus I, what is the result you will get? If you add identity, all the diagonal elements will be raised by 1, increased by 1. So 4 to 0, minus 2, and then plus I, this center element will be 0, and then this is 0, 0, 2. And if you note the given matrix P, okay, 4 to 0, this is 2, 1, 0. Minus 1 becomes minus 2, and 1 becomes 2. That means this is 2p. Okay, so p square plus I is 2p, and hence the value of p square is 2p minus identity. Okay, done. So very basic matrix multiplication question, okay, which you can calculate manually only. Just to show you the solution, I have done it on screen. Now see, normally for W or EC, we can expect some good questions on contour, integral of complex function, but this one is fundamental. Why it is very fundamental? If you know the basics of the Cauchy's theorem. Okay, some people might have elaborated the function and solved it, but just listen to the concept. C be a clockwise oriented closed curve in the complex plane. Okay, C is a closed curve. Okay, C is a closed curve. Let me just see whether this screenshot is visible to all of you or not. I hope it should be visible. Just to save time, I have taken the direct screenshot. Visible? Okay, great. Yeah, Gautam sir, confirm me. So yeah, there is a closed curve defined by mod z equal to 1, that is unit circle given. Further, let fz. Okay, so j is just a complex constant here. What is the function? Jz. Okay, j is just a complex constant. Otherwise, the function is z, or any function z power, and any polynomial function is always analytic. Since it is polynomial nature, okay, since it is polynomial in nature, what I can say that our basic fundamental says that polynomials are always analytic, whether within the unit circle, outside the unit circle, everywhere, it is always analytic. Okay. And dear, what is the Cauchy's theorem? No residue calculation, no Cauchy integral required, because basic Cauchy's theorem says that if there is an analytic function and you integrate any analytic function over a closed curve, its answer is 0. What Cauchy's theorem says that function should be analytic within and on the closed curve. See, but it is here everywhere analytic. So also analytic within the given closed curve. Okay, so the integral is 0. Straight tick. NAT question, no problem. Answer is 0. No need to any elaborate. So for 2 marks, I believe then this is a very fundamental. Okay, very easy, very fundamental for 2 marks. Next question, dear. Okay. Consider the discrete random variable x and y with the probability. Okay, a probability distribution, okay, of 2 random, joint probability distribution of 2 random variables is given to you. Okay, this is the data x0, y0 is this probability, x1 and y0, x0 and y1, and x1 and y1. These are the 4 set of values of x and y with the respective probability. Given x equal to 1, what is the expected value of y? Now, question is simple, but usually such questions in EE were not that much asked. Okay, in EC it is very common, conditional expectation question. It is a question on conditional expectation. Okay, although yes, you know conditional expectation theorem, but this is a question on conditional expectation. What is the conditional expectation? Expected value of y. Given x equal to 1, what is the expected value of y? Okay, given x equal to 1, what is the expected value of y? Okay, normally, how do you calculate the expected value of y? Forget the given condition. Okay, we will do it by summation. Okay, summation y into probabilities, into all the probabilities of y. So summation y, okay, for all values of k, okay, for all the values of k, summation y into all the probabilities of y. Okay, let's say probability y equal to y. Okay, but now this probability has to be calculated as conditional probability, or you can now apply the conditional probability formula, summation of y, okay, into probability y equal to y, given x equal to 1. Okay, that means intersection x equal to 1 divided by probability x equal to 1, isn't it? This is what the conditional probability formula, P of A by B is P of A intersection B upon PB. Okay, now what are the different values of y? Okay, given x equal to 1, okay, given x equal to 1, where is x equal to 1? Given x equal to 1, y may be 0, y may be 1, y may be 0, y may be 1. Okay, so the first value of y is 0. Okay, we have to multiply by y also. And what is the probability? 1 by 8, which is not required, but let me write it. Plus, now summation, what is the next value of y? X equal to 1, the next value of y could be 1. It is have the same probability, 1 by 8 is divided by probability of x equal to 1. What is the probability x equal to 1? When I say probability x equal to 1 means y can take any value. Okay, that means y could be 0 also, 1 also. So both these values to be added, 1 by 8 plus 1 by 8. So total 1 by 8 upon 2 by 8, total answer 1 by 2. Total answer 1 by 2. Or second way of solving it, given x equal to 1, you can draw the probability distribution of y. How? Given x equal to 1, that has already occurred. Then y may be 0 or 1 with equal probability. See, think logically. Given x equal to 1, y may be 0 or 1 with equal probability. Okay, that means y may be 0 or 1 with probability 1 by 2, 1 by 2, and then you can calculate the mean of y alone. That's also a logical method. That is also a logical method that you can apply here. Okay, anyways, let's go to the next question. Okay, so yes, okay, this is what derived distribution with the CDF concept. You must know it. So dear, let x and y be the continuous random variable with the PDF, pxx and pyy respectively. Okay, now let y equal to x square, and given the PDF of x. Okay, given the PDF of x, it's a uniform PDF, fx equal to 1 for any value of x between 0 to 1. For any value of x between 0 to 1. Uniform or rectangular PDF is given to you. Uniform or rectangular PDF is given to you. Okay, so what I will do is I will start here by the CDF of y. Always such cases when you want to derive a distribution, okay, where a function depends on another random variable, CDF of y, let us say capital Y, capital F, Fyy. What is the CDF definition? Probability that this random variable y less than equal to y. Okay, now what is the relation y? Y is equal to x square. Let me write this clearly. What is this relation given? Y equal to x square. The probability x square less than equal to y, or now you can convert to x because x distribution is given. Okay, minus root y less than equal to x less than equal to root y. X square less than y, suppose x square less than 1, so what do you say? X can be any value between minus 1 to 1. Okay, now, wow, probability minus root y to plus root y, but x is not negative here as per the distribution. Okay, so let's say this is some value root y. Okay, what do you want? Probability x less than root y. That means you want this much of the probability. Okay, that means this much of the probability, and the probability can also be equal to area under the PDF under this much of the portion. So area height is 1 and base is root y. Okay, so this is equal to under root y. Okay, so the CDF of y is obtained. Okay, that is root y. And if you want the PDF of y, okay, PDF fy, or they have named it as py of y, and PDF is what? It is the derivative of the CDF. D by dy, it's a y function. Derivative of CDF is known as the PDF. So when you differentiate 1 by root y, your answer is 1 by 2 root y. Y also will belong from 0 to 1 because y is x square. The range of y is automatically clear. Option number A. What is the correct answer here? Option number A, 1 upon root 2y. 1 upon root 2y. This one is a good question. Okay, this one is a good question. Not very difficult, but yes, those who have studied those who have practiced distribution. Okay, but in fact, y equal to x square, if I talk about the same data, x being uniform distribution, is our classroom question, dear. This is nothing but our regular classroom question. We have done the same question in the classroom. Okay, offline class also, online class also. Okay, we have the same question in the classroom. Okay, with the same data. Okay. Okay, so next question. Okay, the signal and system question, a concept. Okay, a concept question. Okay, 2 marks, but okay, 2 marks. Easy one. If you know the basic theory, it is very easy. Why? The continuous time unit impulse signal is applied as an input to a continuous linear time system S. The output is observed to be the continuous time unit step signal. See, what is applied? Continuous time unit impulse signal is applied. Okay, that means whatever the output you obtain when the input is unit impulse signal, that is known as step response. So this output, dear, what is this output? This output should be known as impulse response, isn't it? So on the same concept, 2 questions are there. One on DT, one on CT. Similar, okay, one question they have given for discrete domain. I solved in the beginning of the session, given that the response S of del N, right? If you see the beginning of the video. So 2 concepts, one in CT, one in DT. Okay, 2 questions on same concept. The output for what input? Unit impulse is known as impulse response. Okay, and it is observed to be how much? It is observed to be UT. It is observed to be UT. Okay, then the system is, say, what are the options? Bounded input will produce what type of output? Bounded input producing bounded output or unbounded output is related to the concept of stability. Now, is the impulse response absolutely integrable? Not at all. Because if I draw this impulse response, it is equal to 1. Okay, it is equal to 1. This ht takes the value 1 because it is ut. It is equal to 1 till infinity, and this is not absolutely integrable. We know that when you solve the absolute integration of this, it is not going to be absolutely integrable. Okay, so the system is not BIBO stable. The system is not BIBO stable. And if the system is not BIBO stable, then let us see what is the correct option here. Every bounded input signal applied to S results in the bounded output signal. No, it cannot be guaranteed. That can be guaranteed if there is the stable system. Okay, now it is possible to find a bounded input signal when applied to S results in unbounded. Very correct. Very, very correct. You apply a step. Okay, step convolution, step ramp, where ramp is unbounded. For t tending to infinity, output can go to infinity. So it is possible to find a bounded input signal. Apply a step signal, for example, I'm telling, which is bounded. Okay, then output is input convolution impulse response. Impulse response is also a step signal. Step convolution, step ramp, which will grow to unbounded value. Okay, so which when applied to system results in unbounded output signal? B is definitely correct. Because system is not stable, this is expected. Na? There can be some bounded input signals for which output is unbounded, clearly. Okay, option number C, on applying any input signal to S, the output is always bounded. Wrong. Okay, then that means the system should be stable. Okay, option number D is not clearly visible, but anyways, option number B, it's a MCQ question only. Okay, on applying any input signal, the output is unbounded. No, it's not necessary. I think what I'm able to read in D, on applying any input signal to S, output is unbounded. No, there may be some bounded signals which give bounded output, but not generally, because it is unstable, it is not stable. So there will be some bounded inputs which can definitely give unbounded output, but not every bounded input can give you unbounded output. Okay, so fine. So the correct answer is option number B. That is a very correct answer. Okay, so this is one from another one from signal and system. Some we took in the beginning. This is the next question from signal and system, fundamentals of convolution. See, let the continuous time signal x1 and x2. Some students felt that it is a good question, but this is very, very easy question if you draw the waveforms. What is x1t? Okay, let me start drawing since I spoke about drawing it. This is the x1t. If I talk about the x1 signal, it is 1 for t belonging to 0 to 1. For t belonging to 0 to 1, and it is 2 minus t. Okay, it is 1. Okay, for t equal to 0 to 1, and 2 minus t. Okay, for t equal to 1 to 2. 2 minus 1, it starts from this level only. It has continuity, and then it's a line with negative 1 slope. Okay, till t equal to 2. Let x2t be t. Okay, so from 0 to 1, it is actually t. It is ramp in both the sides, and for 1 to 2, it is the same line. Okay, so this will become a perfect triangle. This will be a perfect triangle. This is the signal x2. Okay, and how much is this height? As I told you, it is t for 0 to 1. This is 1, this is 1, this is 2. Okay, yeah, here I have mentioned everything. Okay, now there is a signal yt which is x1t convolution x2t. Then what is integral? Dear, what is integral yt? Okay, what is integral yt minus infinite to infinite is known as area under yt, is known as area of yt, and yt is convolution of x1 and x2. Apply the area property. Na? Whenever two signals are convoluted, areas are multiplied. Whenever two signals are convoluted, areas are multiplied. So this is equal to area of x1 to be multiplied by the area of x2. Area of x1 multiplied by area of x2. What should be the final answer? Okay, what is the area of x1? Area. Okay, so for this rectangle portion, 1 into 1 and then plus half into base into height. So this one is 1 plus 1 by 2, that is 1.5. That is 1.5. How much is this area? Area of the second waveform, it is half into base into height. Height is 1, base is 2 units. So this one is 1. Okay, so you multiply 1.5 into 1, answer is 1.5. The second one was 1.5. So 1.5, option number B. It is there, it is 1.5, option number B. Okay, the areas are going to be multiplied. Clear, dear? Very clear, very straightforward type of question, you can say, if you are just aware about the convolution properties. If you are just aware about the convolution property, correct? Chalo, done. Next question then. What is the next question? Now this is a differential equation question. Now you can call it in maths or signals anywhere, but I felt solving it by Laplace will be more easy. Consider the ordinary differential equation given to you. X1 dot is 2x2 and further x2 dot is RT with the initial condition x1 0 and x2 0 given to you. If RT is 1 by n for t greater than 0, that means what is RT given to you? What is the RT given to you? Step. Okay, then at t equal to 1, what is the x1t? So I need the information for x1t. Na? So dear, here only what I will do is, okay, x1t depends on x2t, but x2 dot is given. So what I will say, x1 double dot. X1 double dot t is equal to 2x2 dot t, differentiating both sides. That means 2r of t. Okay, 2r of t. X2 dot is rt, correct? Now, dear, taking the Laplace transform on both the sides, for second derivative Laplace transform with initial value, so s square x1s minus s into x1 0 minus x1 dot 0. Initial, that is the derivative property, second derivative property, correct? Na? That is a second derivative property. This is equal to 2RT and step Laplace transform is 1 by s. So that is 2 by s. Now, what is the x1 0? X1 0 is 1 and x1 dot 0. Okay. So see here, what is x1 dot 0? X1 dot 0 should be equal to 2x2 0. But since x2 0 is 0, so x1 dot 0 is also 0. So this value will be 0. So you have s square into x1s minus s is equal to 2 by s. So what is x1s? When you simplify, first s on the right side and divide by s. So 1 by s and 2 by s cube. Correct? So what is the value of x1t? What is the value of x1t? 1 upon s means again step signal, or let me write it as 1. Okay, for t greater than 0. 2 upon s cube, it is the Laplace transform of t square. Okay, t power n factorial n upon s power n plus 1. Okay, so x1t. Okay, now dear, time to write down the answer. Okay, so what is the value of x1? 1. They are asking the value at t equal to 1. So it becomes 1 plus 1 square and it is equal to 2. You can solve it by the normal differential equation method, CF and PI, but I think this is going to be more time saving. I think that is going to be more time saving. Okay, dear. Okay, dear. Yeah, so I think I am done with my questions and I'll now Hemant sir is ready with measurements question. Hemant sir, oh, sir is here. Sir, ready? Yeah. So Hemant sir is ready with measurement question. I think so there are 2 questions of measurement. One marker 1 and 1 is 2 marker. Yeah. All right, guys. Okay. So by this time, guys, approximately I think almost nearly 54-55 questions are already discussed by this time. Okay. Time is about to be 11 p.m. but we are not stopping it. We are not stopping it. Okay, as much as possible, we have done for you. Okay, so roughly 54-55 questions, and I will count it after it. But I guess this much is already done. This much is already discussed. Okay. Yes, dear. So just stay for a while. Hemant sir is going to come up here.
So lastly, we'll look at also the measurements questions. So we have two questions from measurements. Both questions are in fact quite simple questions. So this is, we'll first start with the error calculation. Yeah, so we have two resistors in parallel. The first resistor having a resistance of 100 ohm and the second one having a resistance of 900 ohm. So, you are supposed to tell what is the maximum error when each of the resistor is having an error of 5%. Okay. So basically you have R, the equivalent resistance being equal to R1, R2 divided by R1 plus R2. So we have to calculate this resistance first. What is the equivalent resistance? 100 and 900. So this is 900 into 100 divided by 900 plus 100. So which is denominator is 1000. So when you do the calculation, I think it will turn out to be 9 tubes, right? Yeah. So here we can say that 1 by R is equal to 1 by R1 plus 1 by R2. So this R is the equivalent resistance, and in the equivalent resistance, how much is the error? When you differentiate on both sides, we get minus 1 by R square, okay, into del R becomes equal to minus 1 by R1 square del R1 plus minus 1 by R2 square times del R2, right? So when you send one of the R to the other side and cancelling the minus signs, we get del R divided by R on LHS. Now this becomes equal to R by R1. I'm taking one of the R1 here, and then del R1 by R1 is another term. So del R1 by R1 plus R by, similarly second term, R by R2 into del R2 by R2. Okay. So here it has been given that both of the resistors R1 and R2 are having 5% error. So means del R1 by you can say R1 is 5% in terms of percentage. Even this term is also 5%. Okay. And then we have to substitute the equivalent resistance value, R1 value, R value, R2 value here to get the final answer. So when you do that, so finally the answer becomes equal to R is how much? R is 90. So 90 divided by R1. R1 is equal to 100. So 90 by 100 into 5% plus second term R is 90 divided by 900 into 5%. So you can take 5% common. When you take 5% common, so then we get 90 plus, okay. So sorry, denominator is 900. Yeah, correct. So this becomes equal to 0.9 and this is 0.1. Okay. So 0.9 plus 0.1 becomes how much? This is 0.9 first term, second term is 0.1, and yeah, so plus 0.1, so becomes equal to overall 5%. Okay. So that is a percentage error. I think there is a small change in the slide. So finally in this question the answer is, oh okay, even I think even that is also gone. Yeah. So this is other question. So in this question we have been given a Wheatstone bridge, and we are supposed to find out the sensitivity of the bridge in terms of the change in balancing voltage E for unit change in the resistance R. So where this is the resistance R. Okay. So in terms of millivolts per ohm, so for 1 ohm change in the resistance R, how much in the change in E is what you are supposed to find out. See, currently the bridge is balanced. You can clearly see that bridge is balanced. Okay. So the bridge is balanced. So when the bridge is balanced, why bridge is balanced? Because 50 by 5k is 1 by 100 and this is 10 by 1k which is again 1 by 100. So currently bridge is balanced and hence the value of E becomes equal to 0. Okay. So there is the value of E becomes equal to 0 currently. Now whenever we take R value to be equal to, let's assume 51. Okay, because they said 1 ohm change in R. So I'm taking the value of R to be equal to now 51. Okay. So when R is equal to 51, what is the value of E? So let us calculate. Now in this case, okay, so in this case E becomes equal to, this is 5k. So 5k divided by 5k plus 51 into the overall voltage is nothing but 10 volts minus the other side, it is 10k divided by, 1k. Okay, this is the problem. Okay, I'll just repeat. So when R, sorry. Yeah. So all you have to do is nothing but for 1 ohm change in the R value, this is the R value. So I'm taking the value of R to be equal to 51 here. Okay. So then what is the value of E? The value of E becomes equal to, this is 5k divided by 5k plus 51 into 10 minus, this is 1k divided by 1k plus 10 ohms into 10. Okay. So this is the value of E when R value becomes equal to 51 ohms. So for 1 ohm change in R, we are now finding out how much is the change in E. Okay. So let's do this calculation. So this is okay. So the value that I got is minus 1.96 millivolts. Okay. So this is the value I got. So it means that for 1 ohm change in R, the change in E becomes equal to minus 1.96 millivolts. So all you are supposed to hear when calculating sensitivity, all you are supposed to find out is nothing but magnitude. So in terms of magnitude, so change in E, del E divided by del R. Okay. So how much is this value? Del R is nothing but 1. Because initially it was 50, now it is nothing but 51. So for 1 ohm change in R, how much is the change in E? Initially when the bridge was balanced, the value of E is nothing but 0. Now the value of E is nothing but minus 1.96 millivolts for 1 ohm change in R. Okay. So since you are supposed to express the magnitude, the answer is nothing but in this case 1.96 millivolts per ohm. Okay. So this is the answer. You have to express anyway answer in terms of millivolts per ohm, and the approximate answer is nothing but 1.96 in this scenario. Okay. So yeah, so this is the question, the last question on measurements. So with this, I think we have covered nearly 57 questions in GATE electrical paper, 2025. Okay. Yeah. So yeah, so I hope guys we have done enough justice in terms of paper discussion. Okay, I think we have covered the maximum number of questions as compared to rest all people who have been doing the paper discussion here. Okay, so tomorrow we will do a analysis video in terms of question by question analysis. It's not a generic analysis video, but rather we will do question by question analysis in terms of how the paper was overall, paper toughness level, so that you'll get an idea regarding what would be the cutoffs, what would be the highest mark, what would be probably your rank for the marks that you have got, etc. Okay. Yeah. So with this, we are closing this session. Thanks for joining the session, watching this video, and yeah, we hope that you have done really well in GATE exam. And yeah, people who are preparing also, or who are writing also the EC paper, get ready for the next paper. Okay.